I'm super excited to announce that I am creating a new certification course. This time it is Developing Solutions for Microsoft Azure, which is AZ-204. So let me introduce you to the course. On the first episode, you will learn about all the basic things you need to learn about the examination, from what are the prerequisites for the examination, who is this course intended for, what are the skills you need to be learned to sit for the examination, and how can you schedule the examination. My name is Sushant Sutish and I am going to be your trainer for this entire series. I am certified at an expert level on both Azure and Microsoft 365. You can download this presentation and all other previous presentation by going into aguidetocloud.com. I will make sure to put the link right down in the description where you will be able to download the presentation. If you have any questions, please feel free to reach out to me via LinkedIn. I'm happy to assist you if you need any help. Now let us look into the study areas for this examination. So there are primarily 5 study areas in this examination. On the right hand side, you see different weightages for this examination. These different weightages means the number of questions you can expect on the examination. The higher the weightage means you can expect more questions on this particular study area. As you can see that developing Azure compute solution and connect to and consume Azure and third-party services have more weightage. That means you have to focus more on these study areas. So let me show you what all the things you need to study within these study areas. So to find out more, let's go to the examination page. So search for AZ-204 and you will find the Microsoft certification link for this examination. This is where you can learn about what is this certification about, who is this intended for, things like that. If you are planning to schedule for the examination, please make sure you choose the region here and it will display the appropriate amount for your region. If you scroll down, you will be able to find something called skills measured. These are the 5 different skills we talked about. If you want to know what are the topics comes under each study area, click on Download Examination Skills Profile. This guide is a very handy tool for anybody who is studying for any Microsoft examination. This not only let you know what are the important study areas you need to learn, what are the topics which Microsoft have removed from the previous examination or the previous version of this examination. As you can see, under Developing Azure Compute Solution, it tells you what are the main study areas. It includes learning about Azure Infrastructure as a Service solutions, including how to provision virtual machines, and you need to learn about how you can configure, validate, and deploy Azure ARM templates, etc. Alright, so this is one of the very important resources you can go through to identify what are the study areas you need to be preparing for before sitting for the examination. Now let us understand who is this course for. Microsoft thinks anybody who is an Azure developer or who has any developing background and want to explore Microsoft development solutions are the one who should be appearing for this examination. Or if you want to explore Azure development opportunities, this is the best certification for you. And if you're only particular about learning about Azure development and Azure DevOps, then you don't have to necessarily go and learn about AZ-104, which is around administration. That is really good for any IaaS administrators or who would like to get job as an Azure administrator. AZ-204 can be a stepping stone for an Azure developer, or if you want to proceed and learn about Azure DevOps, this is one of the prerequisites for that examination. Another thing which Microsoft recommend is you need to have at least 1 to 2 years of professional development experience with Microsoft Azure in order for you to completely understand the whole study area in this examination. I have used materials from Microsoft Learn and other Microsoft documentation to prepare this course for you. So while reading the documentation, you might find that I may be using the same reference language as Microsoft because I am completely leveraging the resources which Microsoft provide for this particular content. One additional content which highly encourage you guys to explore is the walkthroughs and the lab guide prepared by Microsoft for this examination or for any other examination. You can find them in GitHub. So let me quickly show you how you can access those. So I'm going to go to the GitHub page. Just type in the examination number and GitHub. Click on the first link. And basically this is where you will be able to find all the resources which can help you prepare for this examination, including learning materials. So if you go under instructions, you can click on demos. This is where you may be able to find a lot of demo guides. And go under the labs. This is where you will be able to find lots of lab materials. So you can listen to the modules which I am teaching. I will make sure to include lots of hands-on wherever possible. I won't be able to go through the entire labs, which you can do it absolutely yourself. All you have to do is go to this particular link, open one of these lab guides. This includes all the instructions you need to learn for starting with these labs. This includes the architectural diagram, step-by-step guide on how you can perform these lab activities, what are the expected results, things like that. Alright, so that concludes the first episode. In the next episode, we are going to start with understanding what is Azure App Service. I'm going to give you an overview of Azure App Service. I will begin with helping you understand what is IaaS, PaaS and SaaS, and what does Microsoft mean by Cloud Shared Responsibility Model. Then we will go and learn about different types of app services, and I will give you an overview of these services. As you consider and evaluate public cloud services, it's critical to understand the shared responsibility model and which security tasks are handled by the cloud provider and which security tasks are handled by you or the customer. The workload responsibility vary depending on whether the workload is focused on software as a service or platform as a service or infrastructure as a service or IaaS. If you are an on-premises customer, you will be responsible for managing the entire stack, from the storage to networking to compute and till the data. So if you look at it, for all the cloud deployment types, you own the data and the identities. You are responsible for protecting the security of your data and identities. Other responsibilities varies based on what type of cloud you choose. If you choose IaaS or infrastructure as a service, Microsoft will be taking care of giving you compute, networking and storage. You and your customer need to only worry about virtual machine, operating system, your application and the data. If you don't want to manage all of this, the best option is to choose platform as a service. Additional to compute, networking and storage, Microsoft will take care of the virtual machine, the operating system and the runtime for you. So you don't have much of a headache of managing your virtual machine, patching your operating system, installing the runtime, things like that. One common example for this platform as a service is Azure SQL or Azure SQL. The third and the most efficient one is software as a service. This is where Microsoft or the cloud provider will take care of most of the things. As a customer, you only have to handle data and access. One of the most common example for this SaaS-based software is Office 365 or Exchange Online, where you only worry about how you configure the application and pretty much everything in the backend will be taken care by Microsoft. So regardless of the type of the deployment, data, endpoints, accounts, and access management are the responsibilities retained by you. Alright, so let's learn about what is App Service. Azure App Service is an HTTP based service for hosting web applications, REST APIs, and mobile backends. You can develop in your favorite language, be it .NET, .NET Core, Java, Ruby, Node.js, PHP, or Python. Applications run and scale with ease on both Windows and Linux based environments. And these app service not only adds the power of Microsoft Azure to your applications such as security, load balancing, auto scaling, and automated management, you can also take advantage of its DevOps capabilities, such as continuous deployment from Azure DevOps, GitHub, Docker Hub, and other sources, package management, staging environments, custom domain, and TLS SSL certificates. Alright, so before I explain you the key features of Azure App Service, I just want to take you to the Azure portal and show you the basic navigation of Azure portal and quickly show you where you can find the Azure App Service. We are not going to create it, I'm just going to show you how you can find Azure App Service. To access Azure portal, you can go to portal.azure.com. Provide your username and password, and then you are into your Azure services or the Azure portal. Basically, from here, you would be able to pick and choose any services of your liking. But please be aware that because it's a cloud service, any service which you run, you are obliged to pay the cost of the service to the provider. So if you are studying or you're a student and you don't have credit, I would highly encourage you to create a free Azure subscription. You can type in create a free Azure subscription and go to the first link what you basically get. When you create your free Microsoft account, you will basically get lots of services for free for 12 months. But more importantly, you will get 200 USD. In my case, it is 300 New Zealand dollars for 1 month. That is plenty enough for you to try out most of the Azure services. And after the first month, you will basically get 25 free Azure services. So you can click on start free, and that's how you can create your free Azure subscription. It basically requires you to have a credit card, though. If you don't have a credit card, that's a problem. But if you do have, you don't have to worry about Microsoft charging you anything. Basically, it's just a verification process. After you create the Azure subscription, you can basically log into the portal just like how I did just now. Basically, let me give you a quick walkthrough of the navigation pane. On the right hand side, on the topmost corner, this is where you will find the account which you use to sign in. You can sign in with multiple accounts. If you want to provide any feedback to Microsoft, this is how you will give your feedback so that Microsoft can improve these services. Any help and support at any point in time while you're navigating through this portal, you would be able to come on to this particular page, and that takes you to the support and troubleshooting page, or you can create your support ticket as well. Or the settings tab will give you option to choose different directories or subscriptions. Let's assume you have multiple subscriptions. In my case, I have multiple subscription, or you would be able to select or deselect these over here. Appearance can be changed. You can decide whether you want the flyout or not. Flyout is what you see on the left hand side. I would always like to have it docked so that I can easily access all the favorite services which I most often use. Theme, I personally prefer the dark mode. It is sometimes very difficult to see things on a dark mode. So these days during the training, I always switch it back to the light mode or the plain mode. Next to the settings window, there is a notification tab. This notification tab will give you information about what activities which is happening at the moment. So you can go ahead and dismiss it if you don't want to see it. And the last but not the least is the Cloud Shell. So we will be talking about Cloud Shell in the future. So we have Bash or PowerShell mode we can choose when we run this Cloud Shell. This is what I call it as global search box into Azure. So if I want to quickly find something, any particular service, I come over here and type in. So for Azure App Service, I'm going to type in App Service. It basically gives you a list of Azure services, and it can sometimes fetch information about a third-party services as well. Another way of finding or creating a resource is going on the left-hand side. You can click on Create a Resource. If you click on Create a Resource, Again, this is where you would be able to search for any service. I'm going to search for app service, hit enter. Okay, this returns the entire service portfolio from not only Azure, from third-party marketplace solutions as well. So Azure has its own marketplace where third-party vendors will be able to host their own solution. Most time it is a one-click solution where you can just click and deploy things like the WordPress or the Trend Micro solutions, what you see over here. So what I want to show you is the web app or the app service, which is the topic for today's conversation. So if I want to create a new app service, all I have to do is hit on create. It basically is going to ask me for a bunch of information. I fill that information and I can create my app service. So we will park it there and we will go and create an first Azure app service and many other services in the future episodes. Now let's go ahead and learn, why do you use Azure app service? One of the key important feature of Azure App Service is to have the ability to use multiple languages and frameworks. App services have first-class support for ASP.NET, ASP.NET Core, Java, Ruby, Node.js, PHP, or Python. You can also run PowerShell and other script or executables as background services. Another feature is managed production environment. What does that mean? App services can automatically patches and maintain the operating system and language frameworks for you. So you can spend time writing great apps and let Azure and Microsoft worry about the platform. Another feature is containerization and Docker. You can Dockerize your app and host a custom Windows or Linux container in app service. And this will give you an ability to run multi-container apps with Docker Compose and migrate your Docker skills directly to app service. Another app service feature is DevOps optimization. You can set up continuous integration and deployment with Azure DevOps, GitHub, Bitbucket, Docker Hub, or Azure Container Registry. And you can promote updates through test and staging environments. This gives you ability to manage your apps in app service by using Azure PowerShell or the cross-platform command line interface or CLI. Azure App Service gives you global scale with high availability. So you can scale up or out manually or automatically. And you can host your apps anywhere in Microsoft Global Data Center infrastructure. And the App Service SLA promises high availability all the time. Okay, next feature is you get to have connections to your SaaS platforms and on-premises data. You can choose from more than 50 connectors from enterprise systems such as SAP, SaaS services such as Salesforce, and internet services such as Facebook. And you can access on-premises data using hybrid connections and Azure Virtual Networks. App Service is also ISO, SOC, and PCI compliant. You will be able to authenticate with users with Azure Active Directory, Google, Facebook, Twitter, or Microsoft accounts. You can additionally create IP address restrictions and manage service identities. Application templates is another great feature. You can choose from an extensive list of application templates in the Azure Marketplace such as WordPress, Joomla, and Drupal. Dedicated tools in Visual Studio and Visual Studio Code streamlines the work of creating, deploying, and debugging for you. And Azure App Service provides turnkey core support for RESTful API scenarios and simplifies mobile app scenarios by enabling authentication, offline data sync, push notifications, and more. You can run a code snippet or script on demand without having to explicitly provision or manage infrastructure and pay only for the compute time your code actually uses. So, this concludes the episode number 2. In the next episode, we are going to learn about Azure App Service Plans. In this episode, we are going to learn about Azure App Service Plan. The different topics we are going to learn is what is Azure App Service Plan, how much does it cost, and some of the common questions you can expect on an app service. So without wasting any more time, let's get into it. Azure App Service include web apps, mobile apps, and API apps. All three of this always runs in an app service plan. In addition, Azure Functions also have the option of running in an app service plan. An app service plan defines a set of compute resources for a web app to run. These compute resources are analogous to the server farm in conventional web hosting. One or more apps can be configured to run on the same computing resources or in the same app service plan. So let's quickly go and find out how you can create an app service plan. I'm on my Azure portal. I'm going to go click on create a new app service and select the Azure app service I want to create. And basically it asks you to provide a bunch of information. The first thing is, where do you want to host this? So if you have multiple subscriptions, so you can choose one from here. I'm going to choose one subscription over here. You can choose an existing resource group or you can create a brand new one. So I'm going to choose an existing resource group, AZ-204, and give a name for your app service. So I'm going to call it as App Service Test AZ-204. Then you have option to either choose a code or Docker container. So we will talk about these things in the later stage. So right now what I want to show you is the app service plan. So the app service plan pricing tier determines the location, features, cost, and compute resources associated with your app. So when you create an app service, the app service plan is created for you, the name. You would be able to change the SKU size here. So click on change size. This will give you an ability to choose different size. As you can see here, there is a specification picker. This will give you an ability to choose, do you want a dev test environment? That adequately displays the different types of pricing tiers you can choose. For mostly for testing, for learning, I would recommend you to pick a plan or a service from this dev test environment. You can click on to see additional options which gives you different pricing tiers as well. For production environments, you have multiple options here. So as you can see that based on a customer requirement, you can pretty much choose any of these different SKUs. Each SKUs have different pricing. Because I'm using a New Zealand subscription, the pricing is in New Zealand dollars. For a P1 V2, it is going to cost me around 122 or nearly $123 approximately if I run this service 24/7 for the whole month. If your workload requires any isolated environment, you have isolated options as well. But the cost will significantly increase based on the option you choose. So the pricing tier of an Azure App Service plan determines what app service features you get and how much you pay for the plan. The pricing tiers available to your app service plan depend on the operating system selected at the creation time. So let's go through different categories for this pricing tier. The first one is shared compute. Shared compute has free and shared. These are the base tiers. You can use this to run an app on the same Azure virtual machine as other app service apps, including apps of other customers. These tiers allocate CPU quotas to each app that runs on the shared resources, and the resources cannot scale out. The next one is dedicated compute. This has basic, standard, premium, and premium version 2. Now additionally you get premium version 3 tiers as well. You will be able to use this to run apps on dedicated Azure virtual machines. Only apps in the same app service plan share the same compute resources. The higher the tier, the more VM instances are available to you for scale out. The last one is isolated. The isolated and isolated version 2 tiers run dedicated Azure virtual machines on dedicated Azure virtual networks. This provides network isolation on top of compute isolation to your applications. It provides the maximum scale out capabilities. Please note that App Service Free and Shared Service plans are base tiers that run on the same Azure virtual machine as other App Service apps. Some apps might belong to other customers, and these tiers are intended to be used only for development and testing purposes. Now that we have learned about Azure App Service Plan and the different pricing tiers, let's look into some of these questions. What if you want to know how you can run and scale your app service? And how much does your app service is going to cost you? And what if you need more features and capabilities for your app service? Let's find that out. The first question is, how does my app service run and scale? In the free and shared tiers, an app receives CPU minutes on shared virtual machine instance and cannot scale out. In other tier, an app can run and scale. So when you create an app in App Service, it is put into an Azure App Service plan. When the app runs, it runs on all the virtual machine instances configured in the App Service plan. If multiple apps are on the same Azure App Service plan, they all share the same VM instances. The next question may be, how much does your app service plan cost you? So let us look into the app service pricing page. As you can see that there are free, shared, basic, standard, premium, and isolated. Except for the free tier, an app service plan carries a charge on the compute resource it uses. In the shared tier, each app receives a quota of CPU minutes, so each app is charged for the CPU quota. In the dedicated compute tiers, which is basic, standard, premium, which include premium version 2 and version 3, the app service plan defines the number of VM instances the apps are scaled to, so each VM instance in app service plan is charged. These VM instances are charged the same regardless of how many apps are running on them. So to avoid unexpected charges, please clean up the app service plan. In the isolated tier, the app service environment defines the number of isolated workers that run your application, and each worker is charged. In addition, in the isolated tier, there is a flat stamp fee for running the app service environment itself. And you don't get charged for using the app service features that are available to you, such as configuring custom domain, TLS SSL certificates, deployment slots, backups, etc. Another question is, what if your app needs more capabilities or features? Your app service plan can be scaled up and down at any time. It is as simple as changing the pricing tier of the plan, and you can choose a lower pricing tier at first and scale up later when you need more app service features. The same works in the reverse as well. When you feel you no longer need the capabilities or features of a higher tier, you can scale down to a lower tier, which saves you money. Alright, so that concludes the episode 3. In the next episode, we are going to learn how to create an Azure App Service web application using Azure Portal. So I will take you through a walkthrough. In this episode, we are going to learn about how can you create an Azure App Service using Azure Portal. And we will learn about how to create a static HTML web app by using Azure Cloud Shell. So without wasting any more time, let's get into it. So one of the prerequisites for this demonstration, if you want to follow along, is to have access to the Azure portal. So once you have a free Azure subscription, you can pretty much do exactly what I'm doing on your Azure portal to learn how to create a static web app. First, let's go to the Azure portal. You can access Azure portal by going into portal.azure.com. After you sign into the Azure portal, go to click on create a resource on the top left hand corner, and on the search box enter Azure web app or web application and hit enter. So here you can see there are a couple of options. So what we are going to pick is web app and hit on create. So this is where we are going to fill out the basic details. The first step is to select the subscription. So you may have a single subscription or you may have multiple subscriptions. So select the right subscription where you would like to host this application. You can click on the drop down button to see the number of subscription you may have. So I'm going to pick one subscription. The second step is to pick the resource group. Resource group is a logical container. So you can separate different deployment by having different resource group. You can differentiate this resource group based on project, workload, etc. So there are two options. One, either you can select an existing resource group or you can create a brand new one. So to create a resource group, all you have to do is click on create new resource group. It basically asks you to provide a name for your resource group. So you can name your resource group based on a project. So I'm going to call this resource group as AZ-204-exam-rg. Then hit enter or OK. The next step is to pick a name for your web application. So the name you choose must be a unique among all Azure web application. And whatever name you're going to give is going to be part of the URL as well. So I'm going to call it AZ-204 sample web app. So the URL is going to look like AZ-204 sample web app dot azurewebsites.net. As you can see that azurewebsite.net is part of this extension. The next step is to select the code or Docker container. In our instance, we are going to select code. The next step is to select runtime stack. So we have multiple runtime stacks like .NET, .NET 5, Java, Node.js, PHP, Python, etc. So we're going to pick .NET 5. So your choice here may affect whether you have a choice of operating system. For some runtime stacks, app service support only one operating system. So the next step is to pick the right operating system. So we're going to keep Windows here because it's the default when you select .NET 5 and above. The next step is to pick a region. So you have plenty of options here. So the right idea behind picking a region is choosing something which is close to you or where your customer is at, because you want this workload to be deployed as close to the customer or as close to the users who are trying to access this service. So I'm going to pick Australia East. The next step is App Service Plan. So I mentioned about App Service Plan on episode 3, where I explained you different types of the plan you can get. So if you have not watched the video, please go ahead and watch it so you understand the different types of App Service Plan you get. So for the Windows plan, we are going to leave the default selection. By default, the wizard will create a new plan in the same region as the web application. And by default, the SKU size is selected as F1, which is free shared infrastructure, where I will only get 1 GB of memory, which is enough for this test environment. After that, you can click on Review and Create to create the deployment. There are other tabs where you can fill details. Deployment. Deployment tab will give you option, do you want to enable continuous deployment or not? So I disabled it. And another tab is monitoring. So we will come to this monitoring tab at the later stage. This is where you get an ability to enable application insight to monitor the application. So for the time being, I'm gonna select no and click on review and create. So on the review and create page, basically it spits out information about all the options we have selected. This is one more chance for us to validate all the inputs what we have given is correct. Once you're satisfied with this information, hit on create. So if you notice on the top information bar on the notification tab, you can see that there is deployment in progress. So you can click on the deployment tab to get more information about what's happening during the deployment. So I'm going to click on this. This takes me to a page where it actually shows you all the activities which is happening in the background right now. So looks like our deployment is complete. So if you want to see all the operations happened, so this is where you can have a look at that. You can directly go to the resource by clicking into go to resource. So let's click on that. All right, so that took us directly into the web app. So it gives you the web app name. Overview page will give you all the information we need to know about the web app. On the left hand side is where you get different option to modify your deployment. So you have the deployment tab where you have information about the deployment slot. Then we have the settings option. So you click on the configuration tab to do any sort of modification or changes to your application. So we will come to these things later. So let's go to the overview pane. So one of the important information on a Azure web app is the URL. So you can access the URL by going into the overview pane. Another way of accessing the URL is by going into clicking on browse button. So to preview your new web app's default content, you only need to select its URL at the top right. So let's select that. This open up in another window. And what you're seeing over here is the placeholder page. This page indicates that your web application is up and running and ready to receive the deployment of your application code. So that completed the first walkthrough. So after every step, my recommendation is to clean up the resources so that you're not charged for any idle resources. So the best way to do it is either deleting the existing resource, or what I would typically do is go to resource group and find the resource group we created for this particular demo. In this case, it is AZ-204 exam resource group. Select that, and right on the overview pane, you can see delete resource group option. So click on delete resource group. As a fail-safe mechanism, Microsoft requests you to provide additional consent in the form of yes or no, or sometimes you have to type in the resource group name. In this case, before deleting, I will have to give the resource group name as a confirmation to delete this resource group. After that, hit on delete. So this is basically deleting or cleaning up the resources what we created, so it is not going to be charged for us. In the next demo, we are going to see how to create a static HTML web app by using Azure Cloud Shell. So our resource group is deleted, what we have used in our previous exercise. This time we are going to use Cloud Shell. To access Cloud Shell, you have to click on this Cloud Shell icon on the top navigation pane. This will give you an ability to open either Bash or PowerShell. So select that. This open the Bash or PowerShell on the browser itself. So you can choose between Bash or PowerShell by going into this switcher. So we're going to select Bash. So what we're going to do is we're going to deploy a basic HTML plus CSS site to the Azure App Service by using the AZ web app command. First, we are going to create a demo directory, and let's change to the directory. Next, we're going to run the following command to clone the sample app repository to your HTML directory. So the cloning is in progress, and as you can see that the clone has been completed. Now let's change the directory. So now let's run the command to create the Azure web app in West Europe, and the name I have given is AZ-204 sample HTML. So this is right now creating the sample HTML web app. The region I chose is West Europe. As you can see that it's already created the resource group. So the resource group name is Rick RG Windows West Europe. We need to take a note of this name so that we can clean up the resource after we complete this exercise. The next step it created is it created the sample HTML. Now it is configuring the default login. It is creating the zip files and the content. So looks like our deployment is completed. So you can get the sample URL from here, what app service plan, where it is located, name of the app, which operating system, the resource group, and the SKU we selected. You can access this URL by just clicking on this URL. I'm going to click on go to the URL. Alright, so now you know that the app is running. The HTML URL is the one which we just now deployed. Alright, so let's go back. So what I'm going to do right now is I'm going to update and redeploy the app. So let's open the code index.html. So this is where you can see the code of this particular static HTML. We're going to change this heading from Azure App Service sample static HTML to just Azure App Service. So I'm going to select this and delete. So if you go back to the HTML page, you can see that the name of the static HTML is Azure App Service sample HTML site. So let's go back here. So I'm going to save it by hitting Control S, and I'm going to quit it by hitting Control Q. So now let's see if we can find that in the Azure portal. So I'm going to go to the resource group. So this is the resource group we created using the Cloud Shell. It's RIC RG Windows West Europe. So I'm going to select that, and you can select the sample HTML. Click on this URL, or you can write, or on the top you can hit the browse as well. So after making the changes, I redeployed the code using the same command we ran before with AZ web app. All you have to use is AZ web app command. Make sure you choose the same region and the correct Azure App Service name. So after it completed the redeployment, you can click on the URL. This time you can see that the name is changed from static HTML to just Azure App Service. Alright, so that completed the episode number 4. I hope the information provided was useful. So you can definitely go ahead and try this by creating a free Azure subscription. In the next episode, we are going to learn about how to configure and monitor Azure App Service apps. In this episode, we are going to learn about how to configure and monitor Azure App Service apps. So without wasting any more time, let's get into it. Application settings hold configuration settings for values that may change, such as a database connection strings. Adding application settings allows you to modify the configuration input to your application without having to change application code. So let me explain you different ways you can configure your application settings. First, let's go to portal.azure.com. Then either use the global search box, or you can use the recently used Azure services to go to Azure App Services. Select an existing app service or create a new one. So I'm going to select an existing app service. On the left hand side, under settings, you can find configuration. Select that. This is where you will be able to find different Azure application settings. So we have application settings, general settings, default documents, and path mappings. In app service, app settings are variables passed as environment variables to the application code. And these app settings are always encrypted when stored. This offers encrypted at rest. And these app settings can also be resolved from Key Vault using Key Vault references. By default, values of app settings are hidden in the portal for security. To see a hidden value of the app settings, click the value field of that settings. You just need to click the show value button. To add a new app settings, click new application settings. And in the dialog, you can stick the settings to the current slot. Once you have a settings, you can go and edit a settings by clicking edit button on the right hand side. And to add or edit app settings in bulk, click advanced edit button and do your modification and click OK. Next topic is connection strings. You can find connection strings right under the application settings. Just like how we discussed the application settings, you can enter your new connection string over here. Provide a name, value, and you can select the type. And to see the hidden values, you can click on show values. And to do bulk modification and bulk edit, you can click on advanced edit. The next topic is general settings. For that, go under settings, click on configuration, Right next to application settings, you can find general settings. This is where you can configure some common settings for the application. Some settings require you to scale up to higher pricing tiers. Under stack settings, this is where you will find the software stack to run the application, including the language and SDK versions. For Linux apps and custom containers, you can select the language runtime version and set an optional startup command or startup command file. And platform settings lets you configure settings for hosted platform, including bitness, which lets you choose 32-bit or 64-bit. You can choose between integrated or classic managed pipeline version, and you can choose to allow all FTP state or FTPS only, or you can disable that state as well. Always on keeps the app loaded even when there is no traffic. When always on is not turned on by default, the app is unloaded after 20 minutes without any incoming request. The unloaded app can cause high latency for any new request because of its warm-up time. When always on is turned on, the front-end load balancer sends a GET request to the application root every 5 minutes. The continuous ping prevents the app from being unloaded. And always on is required for continuous web jobs or for web jobs that are triggered using cron expression. In a multi-instance deployment, ensure that the client is routed to the same instance for the life of the session. You can set the option to off for stateless applications. Enable remote debugging for ASP.NET, ASP.NET Core, or Node.js apps. This option turns off automatically after 48 hours. And incoming client certificates requires client certificates in manual authentication. The next setting we are going to learn is default documents. This setting is only available for Windows apps. The default document is the web page that displays at the root URL for a website. The first matching file in the list is used. If the app uses modules that root based on URL instead of serving static content, there is no need for default documents. You can change the default document settings by going into Settings, Configuration, and select Default Documents. To add a new default document, click on New Document. And after you modify all the values, don't forget to click on Save button. Now let's look into path mappings. For Windows apps, you can customize the Microsoft Internet Information Services or IaaS handler mappings, virtual applications, and directories. You can use handler mappings to add custom script processors to handle requests for specific file extensions. You can add custom storage for your containerized app. Containerized apps include all Linux apps and also the Windows and Linux custom containers running on app service. So select your application, go under settings and configuration and click on path mappings. This is where you will be able to add new handler mapping, and any virtual application and directories for your application can be added on this page. So when adding a new version, which can be a major or minor, it installs side by side with existing versions. You can also manually upgrade your app to the new version. If you configured the runtime in the configuration file, such as web.config and package.json, you need to upgrade by using the same method. If you used an app service settings to configure your runtime version, you can change it in the Azure portal or by running Azure CLI command in the Cloud Shell. To update the application runtime, use the AZ web app config set command with the appropriate parameter for your runtime. The web app does not have a built-in mechanism to update Node.js runtimes. Instead, you can use AZ web app config app settings set command to change the website Node default version application settings to the version of Node.js that you wish to use. To add or edit app settings in bulk, Use this JSON format shown in this slide. Browser security prevents a web page from making requests to a different domain than the one that served the web page. This restriction is called the same origin policy. The same origin policy prevents a malicious site from accessing sensitive data on another site. Sometimes you might want to allow other sites make cross-origin requests, which is known as CORS. CORS is the World Wide Web Consortium, which is known as W3C standard, that allows a server to relax the same origin policy. In standard CORS implementation, In a standard course implementation, the JavaScript client will send a pre-flight request to assess the server's willingness to accept a cross-site request. If allowed, the JavaScript client will then issue a cross-site HTTP request. Now let's learn about how does the operating system and runtime patching work. App Service is a platform as a service, which means that OS and application stacks are managed for you by Microsoft Azure. You only manage your application and its data. Azure manages operating system patching on two levels: the physical server and the guest virtual machines that run Azure App Service resources. Both are updated monthly, and these updates are applied automatically in a way that guarantees the high availability SLA of Azure services. New stable version of supported language runtimes are periodically added to app service instances. Some updates override the existing installation, while others are installed side by side with existing versions. An overwrite installation means that your app automatically runs on the updated runtime. A side by side installation means you must manually migrate your app to take advantages of a new runtime version. Let's look into how you can handle inbound and outbound IP addresses. Azure App Service is a multi tenant service. Apps share network infrastructure with other apps. As a result, the inbound and outbound IP addresses of an app can be different and can even change in certain situations. Regardless of the number of scaled out instances, each app has a single inbound IP address. Sometimes you might want a dedicated static IP address for your application. To get a static inbound IP address, you need to configure an IP based SSL binding. If you don't actually need SSL functionality to secure your app, you can even upload a self signed certificate for this binding. And regardless of the number of scaled out instances, each app has a set number of outbound IP addresses at any given time. Any outbound connection from the app service app, such as connection to backend database, uses one of the outbound IP addresses as the origin IP address. So regardless of the number of scaled out instances, each app has a single inbound IP address. The set of outbound IP addresses for your app changes when you scale your app between the lower tier, which is basic, standard, and premium, and the premium version 2 tier. You can find the set of all possible IP addresses your app can use regardless of the pricing tier by examining the possible outbound IP address property. So that concludes episode 5. In the next episode, we are going to learn about how can you scale your Azure App Service apps. Hey, welcome to episode number 6. In this episode, we are going to learn about auto-scaling concepts and how can you scale up or scale out your Azure App Services. So without wasting any more time, let's get into it. The way to scale up or scale down your Azure App Service plan is to going under settings within your Azure App Service. This will give you an ability to change your Azure App Service plan up or out. Now let us go ahead and understand the concepts of autoscale. Autoscale is a built-in feature of Azure Cloud Services, mobile services, virtual machines, and websites that helps applications perform their best when demand changes. Of course, performance means different things for different applications. Some apps are CPU bound, others memory bound. For example, you could have a web application that handles millions of requests during the day and none at night. Autoscale can scale your services by any of these or by a custom metric you define. So let us have a look into these different autoscale metrics. By default, resource manager based virtual machines and virtual machine scale sets emit basic metrics. So you can use all of these metrics in autoscale rules. If you go to your Azure App Service and on the left hand side, scroll down to monitoring, click on metrics. This is where you would be able to find all the details about different metrics related to this specific web application. You can also perform autoscale based on common web server metrics such as the HTTP queue length. Its metric name is HTTP queue length. This table lists the available server farm metrics. And you can use these different autoscale patterns to scale up or scale down your application. It can be a metric based on CPU, or it can be a duration of your weekdays versus weekends, or you can scale differently during your off work hours, or you can have your own custom metric as well. Azure Monitor Autoscale applies only to virtual machine scale sets, cloud services, app services, web apps, and API management services. This is an example app service running on an Azure Virtual Machine Scale Set or VMSS. So here you can see two examples. One, you can either scale based on a metric or you can scale based on a specific instant count as well. Because I have selected the metric, these are the condition or rules set for this particular metric to drive the auto scale. So the rule says that if the CPU percentage goes up to 75%, increase the instant count by 1. And when the server performance of the CPU goes down below 25, decrease the instant count to 1. And this not only give you ability to put minimum instance count, this gives you an ability to put maximum instance count so that you will not cross beyond that particular instance level. This is another example where we are using a different metrics based on weekdays versus weekends. So in this example, you can see that during weekdays, the instant count is 3 because you are expecting more traffic towards your web application. In this example, we are increasing the instance count to 3 during weekdays, and we are reducing the instance count to 1 during weekends because you are not expecting that much traffic to your web application. This is another example of defining your own custom rule. The custom rule will give you an ability to define your own custom metric parameters based on your business justification or your business requirement. Autoscale settings help ensure that you have the right amount of resources running to handle the fluctuating load of your application. You can configure autoscale settings to be triggered based on metrics that indicate load or performance, or triggered at a scheduled date and time. So this is an example of an autoscale setting schema. This autoscale setting has two metric rules, one for scale out and one for scale in. The scale out is triggered when the virtual machine scale set's average percent CPU is greater than 85% for the past 10 minutes. And the scale in rule is triggered when the virtual machine scale set's average is less than 60% for the past minute. This profile is for special cases. For example, let's say you have an important event coming on December 26, 2020. You want the minimum and maximum capabilities for your resources to be different on that particular day. but still scale on the same metrics. In this case, you should add a fixed date profile to your setting list of profiles, and the profile is configured to run only on the event day. For any other day, Autoscale uses the regular profile. Now let us understand some of the autoscaling concepts. A resource can have only one autoscale setting. An autoscale setting can have one or more profiles, and each profile can have one or more autoscale rules. An autoscale setting scales instances horizontally, which is moved out by increasing the instances and in by decreasing the number of instances. An autoscale setting has a minimum and maximum and a default value of instances. An autoscale job always reads the associated metric to scale by checking if it has crossed the configured threshold for scale out or scale in. And all autoscale failures are logged to the activity log. You can then configure an activity log alert so that you can be notified via email, SMS, or webhooks whenever there is an autoscale failure. Let's understand about autoscale thresholds. With autoscale, you can add the right amount of resources to handle increased load on your application. It also helps you save money by removing the idle resources. You specify a minimum and maximum number of instances to run, and the system will automatically add or remove VMs based on a set of rules. Having a minimum ensures that an application is always running, even under no load. Having a maximum limits your total possible hourly cost. Let us look into an autoscale workflow. Resources emit metrics, and these metrics are later processed by rules. When autoscale rule conditions are met, one or more autoscale actions are triggered. You can add and remove VMs or perform other actions by using automation tools. And the autoscale engine reads an autoscale setting to determine whether to scale up or down. It contains one or more profiles, information about the target resource, and notification settings. Then you can have multiple profiles which enable you to take care of different overlapping requirements. For example, you can have different autoscale profiles for different time of the day of the week. A notification settings define what notification should occur when an autoscale event occurs based on satisfying the criteria of one of the autoscale settings profiles. Now let us look into the best practices of autoscale. First, ensure that the minimum and maximum values are different and have an adequate margin between them. So if you have a setting that has minimum 2 and maximum 2 and the current instance count is 2, no autoscale action can occur. So keep an adequate margin between the maximum and minimum instance count. The next one is manual scaling is reset by autoscale minimum and maximum. So if you manually update the instance count to a value above or below the minimum, the autoscale engine automatically scales back to the minimum. For example, you can set the range between 3 and 6. If you have one running instance, the autoscale engine scales to 3 instances on the next run. Likewise, if you have manually set the scale to 8 instances, on the next run, Autoscale will scale it back to 6 instances. So manual scaling is temporary unless you also reset the autoscale rules. Another best practice is always use a scale out and scaling rule combination that performs an increase and decrease. So if you use only one part of the combination, autoscale will only take action in a single direction. This is not optimal because ideally you want your resources to scale up at times of higher usage to ensure availability, and similarly At times of lower usage, you want your resources to scale down so you can realize cost savings. The next is choose the appropriate statistic for your diagnostic metric. For diagnostic metrics, you can choose among average, minimum, maximum, and total as a metric to scale by. The most common statistic is average. And last but not the least is to choose the thresholds carefully for all metric types. So Microsoft recommend carefully choosing the different thresholds for scale out and scaling based on practical situations. That concludes episode number 6. In the next episode, we are going to learn about Azure App Service staging environments. Hey, welcome to episode number 7. In this episode, we are going to learn about Azure App Service staging environments. I'll explain you the concepts of deployment slots and we will discuss about slots as well. So without wasting any more time, let's get into it. So before I start explaining the concept behind deployment slots, let me quickly show you where you can find the deployment slots. So I logged into my Azure portal, go to App Services. If you don't have an app service created, click on Create to create a brand new one. So I'm going to select the one which I created earlier. And on the left hand side, under Deployment, click on Deployment Slots. And please note that if the application isn't already in standard, premium, and isolated tier, you will receive a message to upgrade your plan. At this point, you have an option to either upgrade or go to the Scale tab of your application before continuing. So I'm going to click on Upgrade. This time I'm going to choose a production workload and I'm going to pick P1 version 2 and hit Apply. So what happening in the backend right now is it's upgrading the app service plan. Looks like the application plan is being upgraded. I'm going to go back to my application and hit refresh. All right. Now you can see there is an option for me to see my deployment slot. On the top, I have an ability to add new slots. Click on add a new slot, give a name, and I'm going to call it as staging. And this is where you have an ability to whether to clone an application configuration from another deployment slot. After making the change, you can hit on add. So while this is happening, you can clone a configuration from any existing slot. Settings that can be cloned include app settings, connection strings, language framework versions, web sockets, HTTP version, and platform bitness. After the slot is added, select close to close the dialog box. Now you can see the new slot is shown on the deployment slot page. By default, the traffic percentage is set to 0 for the new slot, with all customer traffic routed to the production slot. So select the new deployment slot to open the slot's resource page. And the staging slot has a management plane just like any other Azure app service. You can go under settings and you can change anything on this configuration page for this particular slot. And if you go back to the overview page, you can see that the deployment slot has its own host name and is also a live app. So if you want to limit the public access to the deployment slots, you have to modify your Azure App Service IP restrictions. Now let us learn about the deployment slots concepts. When you deploy your web application on Linux, mobile backends, or API app on Azure App Service, you can use a separate deployment slot instead of the default production slot. When you are running in the standard, premium, or isolated app service plan tier, the deployment slots are live apps with their own host names. The app content and the configuration elements can be swapped between two deployment slots, including the production slots. And deploying your application to a non-production slot has following benefits. You can validate app changes in a staging deployment slot before swapping it with the production slot. And deploying an app to a slot first and swapping it into a production makes sure that all instances of the slots are warmed up before being swapped into production. This eliminates downtime when you deploy your application. The traffic redirection is seamless and no requests are dropped because of swap operations. And you can automate this entire workflow by configuring auto swap when pre-swap validation isn't needed. After a swap, the slot with previously staged app now has a previous production app. If the changes swapped into the production slot aren't as you expected, you can perform the same swap immediately to get your last known good side back. AutoSwap streamlines Azure DevOps scenarios where you want to deploy your app continuously with zero cold starts and zero downtime for app customers. When AutoSwap is enabled from a slot into production, every time you push your code, changes to that slot app service automatically swaps the app into production after it's warmed up in the source slot. So let me show you where you can see the auto swap. So go under settings, click on configuration, go under general settings, scroll down till you find deployment slots. This is where you would be able to turn on your deployment slot auto swap. So how do you route traffic between these slots? By default, all client requests to the app production URL are routed to the production slot. However, you can route a portion of the traffic to another slot. This feature is useful if you need user feedback for a new update, but you are not ready to release it to your production environment. Azure PowerShell contains a new AZ web app slot commandlet that you can use to create new deployment slot for an app. To swap a slot, you can manually invoke an Azure Resource Manager action by using invoke AZ Resource Action commandlet. You can use AZ Web Deployment Slot group in the Azure CLI to manage the slot. And you can use create command to create a new slot. And you can use a swap command to swap a slot from source to a destination or a target. That concludes episode number 7. In the next episode, we are going to learn about Azure Functions. In this episode, we are going to learn about Azure Functions overview. Within this episode, we will learn about how to create functions, what are functions inbound and outbound boundings, and some of the best practices for functions. So without wasting any more time, let's get into it. So what is Azure Functions? Azure Functions let you develop serverless applications on Microsoft Azure. You can write just the code you need for problem at hand without worrying about a whole application or infrastructure to run it. We will come back to this portal later on how to create this function app. Now let's go back to the presentation to learn about some of the features of function app. So what can you do with functions? Microsoft Azure Functions is a powerful solution for processing bulk data, integrating systems, working with Internet of Things, and building simple APIs and microservices. Azure includes a series of templates you can use for the key scenarios that are listed on this slide. So consider functions for tasks like image or order processing, file maintenance, or for any task that you want to run on a schedule. Azure Functions support triggers, which are ways to start execution of your code, and bindings, which are ways to simplify coding for input and output data. And Azure Function is a solution for easily running small pieces of code or functions in the cloud. You can write just the code you need for the problem at hand without worrying much about the whole application or the infrastructure to run it. Functions can make development even more productive, and you can use your own development language of choice such as C Sharp, F Sharp, Node.js, Java, or PHP, and pay only for the time your code runs and trust Azure to scale as needed. Azure Functions let you develop serverless applications on Microsoft Azure. Functions is a great solution for processing data, integrating systems, working with Internet of Things, and building simple APIs and microservices. Let's look at various integrations you can do with function. Azure Functions integrate with various Azure and third-party services. These services can trigger your function and start execution, or they can serve as input and output for your code. So now let us look into the various integrations option available. Obviously, you can integrate with Azure Storage, which include Blob, Table, and Queue services. Azure Service Bus, which include topics and queues, notification hubs, Event Grid, Event Hubs, Cosmos DB, and SMS service like Tvilo. Now let us go ahead and create an Azure function using Azure Portal. I'm on my Azure Portal. Go to global search box and type in function and select function app. Click on create to create a new function app. Fill in the basic details like subscription, resource group. I'm going to select an existing resource group. Give a sample function name. I'm going to call it as sample function 231. You have an option to either choose a code or Docker container. I'm going to choose code. Select the runtime stack of your choice. I'm going to select .NET. Pick a version number and region where you would like to host this service. I'm going to pick Australia East. The next is hosting. So when you create a function app in Azure, you must choose a hosting plan for your app. So first step is to create a storage account. Because when you create a function app, you must create or link to a general purpose Azure storage account that support Azure blobs, queues, and table storage. So you can either choose an existing storage account or create a brand new one. So I'm accepting the brand new one which is creating for this particular function app. The next one is picking an operating system. I'm going to stick with Windows. And now we are going to choose an Azure Functions plan. So when you create a function app in Azure, you must choose a hosting plan for your application. There are 3 hosting plans available for Azure Functions: consumption plan, premium plan, and app service plan. The hosting plan you choose dictates the following behaviors: how your function app is scaled, the resources available to each function app instance, and the support for advanced features such as VNet connectivity. Both the consumption and premium plans automatically add compute power when your code is running. Your app is scaled out when needed to handle load and scaled down when code stops running. For the consumption plan, you can also don't have to pay for idle VMs or reserve capacity in advance. And premium plan provide additional capabilities such as premium compute instance, the ability to keep instances warm indefinitely, and VNet connectivity. The app service plan allows you to take advantage of dedicated infrastructure which you manage. Your function app doesn't scale based on events, which means it never scales down to zero. This requires that you need to enable always on. So I'm going to choose the consumption plan and click next. So there is a preview feature at the moment which is called network injection, which is only available with premium and standard. I'm going to go to the next tab, monitoring. I'm not going to enable insights at the moment and click on review and create. Click on create. So right now it is deploying. You can check the status of the deployment by going into notifications. What all activities happening within a deployment can be monitored here under deployment details. So looks like the deployment is completed. Click on go to resource. Alright, so our first function app is been created. So we will come back to this later for explaining more things. Now let's go back to the presentation. Azure Functions are designed to be portable and to be hosted in a variety of places, including Azure Function Service by using resource consumption, premium, or app service plans. Only Linux containers are supported at this moment. So Azure services that support containerization include Azure Kubernetes Service, Service Fabric, and Azure Container Services, or Azure Container Instances, or ACI. Non-Azure container hosts like Kubernetes, virtual machines, and other cloud providers are also supported. You can use Azure Functions on-premises by using Azure App Service on Azure Stack. Now let's understand the concept called trigger. Triggers are what cause a function to run. A trigger defines how a function is invoked, and a function must have exactly one trigger. Triggers have associated data, which is often provided as the payload of the function. There are many types of triggers for Azure services, including HTTP trigger, which is to execute your code by using HTTP request. Then there is timer trigger, which you can use to execute cleanup or other batch tasks on a predefined schedule. GitHub webhook can be used to respond to events that occur in your GitHub repositories. Cosmos DB trigger can be used to process Azure Cosmos DB documents when they are added or updated in collections in a NoSQL database. Blob trigger can be used to process Azure storage blobs when they are added to containers. You might use this function for image resizing. Queue trigger can be used to respond to messages as they arrive in an Azure storage queue. Let's understand binding. Binding to a function is a way of declaratively connecting another resource to the function. Bindings may be connected as input bindings, output bindings, or both. Data from bindings is provided to the function as parameters. You can mix and match different bindings to suit your needs. And bindings are optional, and a function might have one or multiple inputs or outputs as bindings. In this example, the function is triggered by a recurring schedule nightly and queries Azure Cosmos DB for a set of documents. The function then processes the documents, outputs blobs to Azure storage, and outputs logs to event hubs. And these triggers and bindings lets you avoid hard coding access to other services. And your function receives data, for example, the content of a queue message in function parameters. You send data, for example, to create a queue message by using the return value of the function. This is a simple Java function which provides echo functionality by taking in the body of a HTTP post request as a string and returning that same body as a response. This sample Python function is triggered by the creation of new Azure storage blob. When triggered, it logs information about the blob. Under the premium plan, Azure Functions has the same hosting capabilities as the web apps in Azure App Service. This means that Azure Functions also has the virtual network integration feature. When virtual network integration is used with Azure Virtual Network in the same region as your app, it requires you to use a delegated subnet with at least 32 addresses in it. You won't be able to use the subnet for anything else. Outbound calls from your app will be made from the addresses in the delegated subnet. When you use this version of virtual network integration, the calls are made from addresses in your virtual network. Using addresses in your VNet enables your app to make calls to service endpoint secured services, access resources across Azure Express Route connections, access resources in virtual network that you are connected to, and access resources across peered connections, including Express Route connections. So let's close off this episode by looking into some of the best practices of functions. First, avoid long-running functions. Large, long-running functions can cause unexpected timeout issues. A function can become large due to many Node.js dependencies. Next is to use cross-function communication. Durable functions and Azure Logic Apps are built to manage state transitions and communication between multiple functions. If you are not using durable functions or logic apps to integrate with multiple functions, it is generally a best practice to use storage queues for cross-function communication. The main reason is storage queues are less costly and much easier to provision. Another best practice is to write your functions as stateless. Functions should be stateless and idempotent if possible. Associate any required state information with your data. And last but not the least, and write defensive functions. Assume that your function could encounter an exception at any time. So design your functions with the ability to continue from a previous fail point during the next execution. That concludes this episode. In the next episode, we are going to learn about developing Azure functions. In this lesson, we are going to learn about developing Azure functions. Within that, we are going to learn about function folder structure, function code, binding configuration, and binding base code. Let us start with understanding the function folder structure. The code for all the functions in a specific function app is located in a root project folder that contains a host configuration file and one or more subfolders. Each subfolder contains the code for a separate function. The host.json file contains runtime specific configurations and is in the root folder of the function app. A bin folder contains packages and other library files that the function app requires. The functions editor built into the Azure portal lets you update your code and your function.json file directly inline. This is recommended only for small changes or proof of concept. Best practice is to use a local development tool like VS Code. You can use the Azure Functions extension for Microsoft Visual Studio Code to locally develop functions and deploy them to Azure. By using the Azure Functions extension, you can edit, build, and run functions on your local development computer, publish your Azure Functions project directly to Azure, and write your functions in various languages while utilizing the benefits of Visual Studio Code. Let's look at Azure Functions in Visual Studio. Azure Functions is a built-in project type for Visual Studio that lets you develop, test, and deploy C# functions to Azure. So by using the Azure Functions project type enables you to edit, build, and run functions, publish it to your Azure Functions project directly by Azure, or you could use web jobs attributes to declare functions bindings directly to the C# code instead of maintaining a separate function.json for binding definitions. Then you can create your functions in C# while retaining all the benefits of Visual Studio development. So let's look at a function code. The C# class represents a basic queue storage trigger function. A binding specific attribute is applied to each binding parameter supplied to the entry point method. The attribute takes the binding information as parameters. Suppose you want to write a new row to Azure Table Storage whenever a new message appears in the Azure Queue Storage. You can implement this scenario by using the Azure Queue Storage trigger and an Azure Table Storage output binding. The first element in the binding array is the queue storage trigger. The second element in the binding array is the Azure Table Storage output binding. Here is the C# script code that works with the trigger and binding. Notice that the name of the parameter that provides the queue message content is order. This name is required because the name property value in the function.json is order. So let us look into the function app settings. Any settings that you add in the local.settings.json must be also added to the function app in Azure. These settings are not uploaded automatically when you publish the project. The easiest way to upload the required setting to your function app in Azure is to use the Manage Application Setting link that is displayed after you successfully publish your project. You can also manage application settings in the other ways. Other ways are by either using an Azure portal or by using Publish Local Settings Publish option in the Azure Functions Core tools. Or you can use Azure CLI as well. That concludes this lesson. In the next lesson, we are going to learn about how to implement durable functions. In this lesson, we are going to learn about durable functions. The topics we are going to learn within this lesson includes durable function types and different durable function scenarios, including chaining and fan-in and fan-out. Durable functions is an extension of Azure Functions and Azure Web Jobs that lets you write stateful functions in a serverless environment. The extensions manage state, checkpoints, and restarts for you. And the extension lets you define stateful workflows in a new type of function called an orchestrator function. So let's look at some of the advantages of orchestrator functions. They define workflows in code, so no JSON schemas or designers are needed. They can call other functions synchronously and asynchronously. Output from called functions can be saved to local variables, and they can automatically checkpoint their progress whenever the function awaits. So the local state is never lost if the processes recycles or the virtual machine reboots. Please note that durable functions is an advanced extension for Azure Functions that is not appropriate for all applications. The rest of the lesson assumes that you have a strong familiarity with Azure Functions concepts and the challenges involved in serverless application development. Let us look into different types of durable functions. There are currently four durable functions types in Azure Functions: orchestrator, activity, entity, and clients. Let's learn about orchestrator first. Orchestrator defines function workflows using procedural code, and you can call other durable functions synchronously and asynchronously. The total lifespan of an orchestration instance can be seconds, days, months, or never ending. Now let us look into activity. Activity functions are the functions and tasks that are orchestrated in the process. For example, you might create an orchestrator function to process an order. The task involve checking the inventory, charging the customer, and creating a shipment. Each task would be a separate activity function, and these activities can be executed serially, in parallel, or some combination of both. The third type is called entity. Entity functions are a functions with a special trigger type, which is known as entity trigger. This can be invoked from client functions or from orchestrator functions. And entities manages state explicitly. The last type is called client. Client sends the message to the task hub used to trigger orchestration and entity trigger bindings. So what makes a function a client function? This is its use of the durable client output binding. So let us look into a function scenario. The scenario is called chaining. Function chaining refers to the pattern of executing a sequence of functions in a particular order. Often, the output of one functions need to be applied to the input of another function. The second scenario is chaining code. The values f1, f2, f3, and f4 are the names of other functions in the function app. Control flow is implemented by using normal coding constructs. That is, code executes top down and can involve existing language control flow semantics and conditions and loops. Error handling logic can be included in try, catch, finally as blocks. The third scenario is fan out and fan in. Fan out, fan in refers to the pattern of executing multiple functions in parallel and then waiting for all to finish. Often, some aggregation work is done on result returned from the functions. With normal functions, fanning out can be done by having the function send multiple messages to a queue. However, fanning back is much more challenging. You would have to write code to track when the queue triggered functions end and store function outputs. The durable functions extension handles this pattern with relatively simple code. Let's look at a fan out scenario. The fan out work is distributed to multiple instances of function F2, and the work is tracked by using a dynamic list of tasks. The third pattern is all about the problem of coordinating the scale of long running operations with external clients. A common way to implement this pattern is by having a long running action triggered by the HTTP call and then redirecting the client to a status endpoint that they can poll to learn when the operation completes. Because the state is managed by the durable functions runtime, you don't have to implement your own status tracking mechanism. The next scenario is monitoring. The monitor pattern refers to a flexible recurring process in a workflow. For example, polling until certain conditions are met. A regular timer trigger can address a simple scenario, such as a periodic cleanup job, but its interval is static and managing instance lifetimes becomes complex. Durable functions enable flexible recurrence intervals, task lifetime management, and the ability to create multiple monitor processes from a single orchestration. Another scenario is human interaction. Many processes involve some kind of human interaction. The tricky thing about involving humans in an automated process is that people are not always as highly available and responsive as cloud services. Automated processes must allow for this, and they often do so by using timeouts and compensation logic. So, this completes the lesson on durable functions. In the next lesson, we are going to learn about how to develop solutions that use blob storage. In this lesson, we are going to learn about Azure Blob Storage and how can you develop solution using Azure Blob Storage. And within this lesson, we are going to learn about different types of Azure storage and what are the different types of blob storage available in Azure. Let us start with understanding how to find an Azure storage account or how to create an Azure storage account. You can go to the global search box and type in storage account and select that. If you want to create a brand new storage account, you can click on create. You can see all the existing storage account what you have in your subscription on this page. If you want to create a brand new one, click on create. This basically asks you for some basic information like subscription, resource group where you want to host it, what's the name you want to give to the storage account, where do you want to host this storage account, what type of performance you are looking for. Standard gives you a hard disk performance and premium gives you an SSD performance. Then you can choose different redundancy. What is LRS, GRS and ZRS and GZRS are all explained on the other video which I made before. So if you want to learn more about storage account in detail, you can watch one of my AZ-104 videos, which clearly explains all of these intricate components. Once you select all of these right components, you can hit on review and create to create your first storage account. So let me take you to an existing storage account. So once you go inside a storage account, under the overview tab, you can get the information what you filled out to create the storage account, like what's the performance, where is it hosted, things like that. Under data storage on the left hand side, you can see there are four types of storage. One is Blob, which is blob based container. That is what we are going to learn in this lesson. Then we have file shares for the SMB drives, then queues and tables. Let's go back to the presentation to learn more about Azure Storage Overview. An Azure Storage account contains all of your Azure Storage data objects, which include blobs, files, queues, tables, and disk. The storage account provides a unique namespace for your Azure storage data that is accessible from anywhere in the world over HTTP or HTTPS. Data in your Azure storage account is durable and highly available, secure, and massively scalable. Now let's talk about Azure Blob Storage in detail. Microsoft Azure Blob Storage is the Microsoft object storage solution for the cloud. Blob storage is optimized for storing massive amounts of unstructured data. Unstructured data is data that does not adhere to a particular data model or definition such as text or binary data. Users or client application can access objects in blob storage via HTTP or HTTPS from anywhere in the world. Objects in the blob storage are accessible via Azure REST APIs or Azure PowerShell, Azure CLI, or Azure Storage Client Library. So if you're wondering what are the available client libraries, you can use languages including .NET, Java, Node.js, Python, Go, PHP, and Ruby. Let us learn about the blob storage resource hierarchy. Azure Blob Storage allows access to stored data through its resources. Azure Blob Storage contains storage account, This refers to an account that you can use to access Azure storage. In terms of hierarchy, it's the parent account of the container and blob resources. The next layer is the container layer. This refers to a collection of objects that are grouped together and accessed by using the same base uniform resource identifier or URI. And the third layer is blob. This refers to an object, typically a media file or a disk, that is stored in the container. So let me take you to the Azure portal and show you how this looks like. So I'm on my Azure portal. Go to a storage account. Under the data storage, click on containers. This is how you can access a blob storage. You can click on create a container. This is how you name a container. And you can set the public access level. If you want to do additional controls like encryption, you can do that over here. Click on create a container. So now you have the blob storage and you have a container. The third layer is the object what you place within the container. This could be an image file or an MP4 file or a JPEG file or whatever file you want to put in. So you can basically upload the file by clicking on upload here, select the file which you want to upload, or you could use other tools like Azure CLI, AZ Copy, or Storage Explorer to upload and download and manipulate these files. To access this blob, you can create access policies or you can create shared access token as well, which will give you a unique URI which specifies who's got access to what at what particular time and the level of access. Now let us learn about the blob types. Azure Storage supports three types of blobs: block blobs, append blobs, and page blobs. Each blob type is designed to handle a specific type of object in storage. For example, block blobs are ideal for media files, append blobs are suitable for log files, and page blobs almost directly emulate storage disk. So let's find out about the different blob types that are available for storage. First, learn about the block blobs. Block blobs let you upload large blob efficiently. Each block is identified by the block ID. You create or modify a block blob by writing a set of blocks and committing them by their block IDs. Let's examine the characteristics of append blobs. An append blob comprises blocks and is optimized for append operations. When you modify an append blob, blocks are added to the end of the blob only through the append block operation. Updating or deleting existing block isn't supported. What about page blobs? Page blobs are a collection of 512 byte pages that are optimized for random read and write operations. They are like hard disk storage and are ideal for virtual hard disk. To create page blob, you initialize the page blob and specify the maximum size of the page blob that needs to grow. To add or update the content in the page blob, you write a page or pages by specifying an offset and a range that aligns to the 512 byte page boundaries. So let's look at the storage durability options. The first one is LRS, which is known as locally redundant storage. This replicates data 3 times within a single data center. LRS provides at least 99.119% durability of objects over a given year. LRS is the lowest cost replication options and it offers the least durability compared to other options. The next one is ZRS or zone redundant storage. This replicates data synchronously across 3 storage clusters in a single region. Each storage cluster is physically separate from the others and is in its own availability zone. The third type is GRS. GRS is known as geo-redundant storage. This is designed to provide at least 99.69% durability of objects over a given year by replicating data to a secondary region that's a hundreds of miles away from the primary region. And the fourth type is RAGRS, which is known as Read Access Geo-Redundant Storage. This is based on GRS, but RAGRS replicates data to another data center in a secondary region, and it also provides the option to read them from the secondary region. The next one is GZRS, which is known as Geographically Zone Redundant Storage. This combines the high availability of ZRS with the protection from the region outages that GRS provides. And optionally, you can enable read access to the data in the secondary region with read access geographically zoned redundant storage if your applications must read data in the event of a disaster in the primary region. Now let us go ahead and create an Azure Blob storage using Azure Portal. So go to all services and select storage accounts and click on create. So click on the subscription. You can create a new resource group, or you can select an existing one. I'm selecting an existing resource group. In the storage account name field, enter a name for your account. But please note that the name must be unique across Azure, and the name must be between 3 and 24 characters long, and the name can include only numbers and lowercase letters. So I'm going to name test123 test321 storage, and I hope nobody reserved it before. All right. And in the region field, select the location of the storage account or use the default one. I'm just going to use the default one. Under performance, I'm going to keep it standard. And under redundancy, I'm going to keep it locally redundant storage. Click next. This is where you can modify the advanced security features. I'm not going to do any modification at the moment. Go to networking. This gives you an ability to enable public endpoint with selected network, or private endpoint options. Under data protection, you have option to enable soft delete. You can enable point-in-time restore for containers, etc. Click next for encryption. If you do want to modify any encryption type, this is where you can do that. I'm just going to pretty much leave all the values to the default and click on review and create. So right now it is completed the validation. You get the green message saying that the validation has been passed. Click on create. Storage account creation won't take more than a minute. So after completion of this deployment, we can jump right into the storage account. Looks like our storage account is created successfully. Click on go to resource to go directly to the storage account. So within this storage account, like we saw before, you can go under data storage and you can click on blob container. This is where you do it. So since we have seen that example, I'm going to go back to the overview tab and I'm going to click on delete, and I'm going to type the name of the storage account, and I'm going to delete this resource, because this is one way I make sure that my subscription doesn't exhaust all the credit I have. So this is called cleanup. Alright, so that concludes this lesson. In the next lesson, we are going to learn about how to manage the Azure Blob Storage Lifecycle. In this lesson, we are going to learn about how to manage Azure Blob Storage Lifecycle. And within this lesson, we are going to learn about different Azure storage tier and storage pricing as well. Azure Storage offers different storage tiers, which allows you to store blob storage object data in the most cost-effective manner. The available tiers include Premium Storage, which is a performance tier optimized for mission-critical high-performance applications. This is currently available only for blob storage. Then there are other 3 access tiers currently available in the standard performance tier for general purpose V2 account types. Let's look into these one by one. The hot storage is optimized for storing data that is accessed frequently. The cool storage is optimized for storing data that is infrequently accessed and stored for at least 30 days. The archive storage is optimized for storing data that's rarely accessed and is stored for at least 180 days with flexible latency requirement. And these latencies can be in the order of hours. And these different storage tiers have some other consideration you have to take care. The archive storage tier is only available at the blob level and not at the storage account level. And the data in the cool storage tier can tolerate slightly lower availability, but it still requires high durability and similar time to access and throughput characteristics as hot data. Let's look into the storage tier pricing. The premium performance tier, block blobs only, and the hot access tier have the highest cost per GB per month for the data. The cool and archive access tiers have better price rates for large quantities of data. The premium performance tier and the hot access tier have the lowest cost per 10,000 read operations because they are designed for highly transactional data. The cool and archive access tiers are priced optimized for storage rather than transactions. The cool and archive tiers have higher cost for large transactional workloads. Let's look into the lifecycle management for these storage accounts. Azure Blob Storage Lifecycle Management offers a rich rule-based policy for general purpose V2 and Blob storage accounts. You can use the policy to transition your data to the appropriate access tiers or to expire it at the end of the data's lifecycle. A lifecycle management policy lets you transition blobs to a cooler storage tier or delete blobs at the end of their life cycles or define rules to run once per day at the storage account level. Let's look at an example of a lifecycle management workflow. In this scenario, hot storage is best during the early stages and the cool storage is most appropriate for occasional access. And the archive storage is the best tier option after the data ages more than a month. By adjusting storage tiers with respect to the age of the data, you can design the least expensive storage option for your needs. To achieve this transition, lifecycle management policy rules are available to move aging data to cooler tiers. Let's look at a policy example. A policy must include at least one rule, and you can define up to 100 rules in a policy. A rule name can include up to 256 alphanumeric characters, and the name is case sensitive. It must be unique within a policy. Each rule definition is made up of a filter set and an action set. That concludes this lesson. In the next episode, we are going to learn about Azure Cosmos DB overview. Within this lesson, we will learn about Azure Cosmos DB core functionalities, global replication, consistency levels, and Azure Cosmos DB APIs. Today's applications must be highly responsive and always online. One of the most obvious challenges when maintaining a relational database system is that most relational engines apply locks and latches to enforce strict atomicity, consistency, isolation, durability semantics. This approach provides benefit in terms of ensuring a consistent data state within the database. However, there are heavy trade-offs with respect to concurrency, latency, and availability. To achieve low latency and high availability, you must deploy instances of a database engine in data centers that are close to their users. Databases then need to respond in real time to significant amounts of changes in usage at peak hours, store ever increasing volumes of data, and make this data available to users in milliseconds. Microsoft Azure Cosmos DB is a database service native to Azure that focuses on providing a high performance database regardless of your selected API or data model. You can deploy Azure Cosmos DB worldwide across all Azure regions, which helps you overcome the previously mentioned challenges of maintaining a relational database system. Additionally, Azure Cosmos DB provides a solution for big data applications by providing the capacity for high volume, velocity, and variety in the data. The data stored in Azure Cosmos DB can be integrated with HT Insight for big data analytics via Apache Spark jobs. Azure Cosmos DB has four core features that are the same regardless of which API you choose. They are global replication, varied consistency levels, low latency, and elastic scale out. Azure Cosmos DB has a feature referred to as a turnkey global distribution that automatically replicates data to other Azure data centers across the globe without the need to manually write code or build a replication infrastructure. Let us look into the Azure Cosmos DB consistency levels. Azure Cosmos DB provides 5 consistency levels: strong, bounded staleness, session, consistent prefix, and eventual. The consistency levels range from very strong consistency, where reads are guaranteed to be visible across replica before a write is fully committed across all replicas, to eventual consistency, where writes are readable immediately and replicas are eventually consistent with the primary. Let's look into Azure Cosmos DB's APIs. Azure Cosmos DB can be accessed by using 5 different APIs. The underlying data structure in Azure Cosmos DB is a data model based on Atom record sequence that enabled Azure Cosmos DB to support multiple data models. Because of the flexible nature of the Atom record sequences, Azure Cosmos DB will be able to support many more models and APIs over time. The MongoDB API in Azure Cosmos DB acts as a massively scalable MongoDB service provided by the Azure Cosmos DB platform. It is compatible with existing MongoDB libraries, drivers, tools, and applications. The Table API in the Azure Cosmos DB is a key value database service built to provide premium capabilities. For example, automatic indexing, guaranteed low latency, and global distribution. And the Gremlin API in the Azure Cosmos DB is a fully managed, horizontally scalable graph database service that makes it easy to build and run applications that work with highly connected datasets supporting open graph APIs. The Cassandra API in Azure Cosmos DB is a globally distributed Apache Cassandra service powered by the Azure Cosmos DB platform. This is compatible with existing Apache Cassandra libraries, drivers, tools, and applications. The SQL API in Azure Cosmos DB is a JavaScript and JSON native API based on Azure Cosmos DB database engine. Now that we have understood all the API calls you can make from Azure Cosmos DB, let's look into how can you migrate from NoSQL. To achieve a successful migration, it is important to keep few tips in mind. So instead of writing custom code, you should use native tools such as the Cassandra Shell, MongoDB, or Mongo Export. Azure Cosmos DB containers should be allowed prior to the migration with the appropriate throughput levels set. Many of the tools will create containers for you with default settings that are not ideal. Prior to migrating, you should increase the container's throughput to at least 1000 request units per second so that the import tools are not throttled. And Azure Cosmos DB has a MongoDB API and Cassandra API to provide a NoSQL service offering for two of the most popular NoSQL database platforms. And both APIs are protocol compatible, with the Cassandra API supporting CQL version 4 and the MongoDB API supporting MongoDB version 5. Many applications can be lifted and shifted to Azure Cosmos DB without the need to rewrite the code. So let's look at the Cosmos DB throughput before we conclude this lesson. You can think of request units per second as the currency for throughput. RUs per seconds is a rate-based currency. It abstracts the system resources such as CPU, IOPS, and memory that are required to perform the database operations supported by Azure Cosmos DB. Costs are always measured in RUs no matter which API you are using. That concludes this lesson. In the next one, we are going to learn about how to create Cosmos DB resources and data structure. In this lesson, we are going to learn about how to create an Azure Cosmos DB and the resource hierarchy. Alright, so first let's go to the Azure portal and learn about how can you create Azure Cosmos DB resources using Azure portal. So go to portal.azure.com and sign in with your credentials. On your home page, on the left hand side, click on Create a Resource. In the new page, you can either search for Azure Cosmos DB here, or you can find Azure Cosmos DB on the home page itself and click on Create. On the Select API option page, click on Create on the Core SQL recommended box. And in the Create Azure Cosmos DB account page, enter the basic settings for the new Azure Cosmos DB account. Select the subscription, create a new resource group or pick an existing one. Under the account name, enter a unique name to identify your Azure Cosmos DB account. The name can only contain lowercase letters, numbers, and the hyphen character. It must be between 3 to 31 characters in length. Under location, use the location that is closest to your users to give them the fastest access to the data. Under the capacity mode, select serverless and click on review and create. So validation has been successful. Click on create to create the Cosmos DB account. The deployment is in progress now. Alright, so the deployment has been completed. You can click on go to resource, go to your Azure Cosmos DB account. So let's look into how you can add a database and a container. On the left hand side, click on Data Explorer and click on create a new container. So provide a database ID, leave it as create new, and I'm gonna create as to-do list, container ID as items, and partition key as category, and leave the rest of the values as default and click on OK. Now let me show you how you can add data to your database. So we are going to perform the same activity under the Data Explorer, expand the to-do list database, and expand the items container, and next select items and then select new item, and I'm going to add the following structure to the document on the right side, and you can hit save. And now you can select new document again and create and save another document with a unique ID and any other properties and values you want. And your documents can have any structure because Azure Cosmos DB doesn't impose any schema on your data. As always, I'm going to go back to the Cosmos DB we created and I'm going to delete the account. To delete it, I have to give the name for the Cosmos DB and delete it. So I'm doing this to save the cost or the credit on my test Azure subscription. Alright, so now let's go back to the presentation. So let's look into the resource hierarchy. So the JSON documents stored in the Azure Cosmos DB SQL API are managed through a well-defined hierarchy of database resources. The Azure Cosmos DB hierarchical resource model consists of set of resources under a database account, each addressable via a logical and stable URI. A set of resources is referred to as a feed in Azure Cosmos DB. A database account is associated with a set of databases and a fixed amount of large object storage for attachments. You can create one or more database account by using your Azure subscription. A database is a logical container of document storage partitioned across collections, and it is also a user's container. A collection is a container of JSON documents and the associated JavaScript application logic. A document is a user-defined JSON content, and by default, no schema needs to be defined, nor do secondary indexes need to be provided for all the documents added to a collection. Under stored procedure, application logic written in JavaScript that is registered with a collection and executed within the database engine as a transaction. In the Azure Cosmos DB SQL API, databases are essentially containers for collections, and collections are where you place individual documents. A collection is intrinsically elastic. It automatically grows and shrinks as you add or remove documents. What about partitioning? Azure Cosmos DB provides containers for storing data called collections, graphs, or tables. Containers are logical resources and can span one or more physical partitions or servers. The number of partitions is determined by Azure Cosmos DB based on the storage size and throughput provisioned for a container or set of containers. If you are already familiar with the shredding pattern, the idea of dynamic partitioning is not very different. So how can you implement partition? So let's look at partitioning implementation. A logical partition is a partition within a physical partition that stores all the data associated with a single partition key value. Partition ranges can be dynamically subdivided to seamlessly grow the database as the application grows while simultaneously maintaining high availability. When a container meets the partitioning prerequisites, partitioning is completely transparent to your application. Azure Cosmos DB handles distributing data across physical and logical partition and routing query requests to the right partition. That concludes this lesson. In the next episode, we are going to learn about how to implement IaaS based solutions. In this lesson, we are going to learn about how to implement Azure IaaS solutions. And within this lesson, we will learn about Azure Virtual Machine Checklist, how to name a virtual machine, and what are the virtual machine sizes, standards, and pricing. Provisioning virtual machines to Microsoft Azure requires planning. The items listed in this checklist provides a subset of the things one should consider before creating a virtual machine. So things you can consider are the names of your application resources, the location where the resources are stored, size of the virtual machine, maximum number of VMs that can be created, the operating system that the VM runs, configuration of the VM after it starts, and the related resources that the VM needs. Let's look into naming. A virtual machine has a name assigned to it and it has a computer name configured as part of the operating system. The name of the VM can be up to 15 characters. So if you use Azure to create the operating system disk, the computer name and the virtual machine name are the same. If you upload and use your own image that contains a previously configured operating system and use it to create a virtual machine, the names can be different. Microsoft recommend that when you upload your own image file, you make the computer name in the operating system and the virtual machine name the same. So this table offers a set of best practices you can use when you name a virtual machine. For example, depending on the environment, you could put dev, and if it is hosted in US East, you could do dev UE. If you have multiple instances, you can name based on the count and add a service or a product name and the role of the application which is running. Let's look into VM pricing models. There are two separate costs the subscription will be charged for every virtual machine: compute and storage. By separating these costs, you scale them independently and only pay for what you need. Let's look into the compute cost first. Compute expenses are priced on a per hour basis but billed on a per minute basis. You are not charged for compute capacity if you stop and deallocate the virtual machine because this releases the hardware. The hourly price varies based on the virtual machine size and the operating system you select. The cost for a virtual machine includes the charge for the Windows operating system. Linux based instances are less expensive because there is no operating system license charge. Now let's look into the storage cost. You are charged separately for the storage the VM uses. The status of the VM has no relation to the storage charges that will be incurred. Even if the VM is stopped and deallocated and you aren't built for running the VM, you will be charged for storage used by the disk. And there are two other payment options for this compute cost. One is pay as you go and reserved instance. With the pay as you go option, you pay for the compute capacity by the second with no long term commitment or upfront payments. With reserved instances, the reserved virtual machine instance option is an advanced purchase of a virtual machine for 1 or 3 years in a specified region. The commitment is made upfront, and in return, you get up to 72% price savings compared to the pay as you go pricing. Our rights are flexible and can easily be exchanged or returned for an early termination fee. Let's look into VM storage options. Azure Storage is the Microsoft cloud-based data storage solution. It supports almost any type of data and provides security, redundancy, and scalable access to the stored data. A storage account provides access to objects in Azure Storage for a specific subscription. Virtual machines always have one or more storage accounts to hold each attached virtual disk. You can use Azure Premium Storage for production workloads, especially those that are sensitive to performance variation or IO intensive. For development or testing, standard storage is suitable. Within the storage, there are two things we need to understand: managed and unmanaged disk. First, let's look into managed disk. Managed disk are the newer and recommended disk storage model. They elegantly solve this complexity by putting the burden of managing the storage account into Azure. You specify the size of the disk, which can be up to 4 terabytes, and Azure creates and manages both the disk and the storage. You don't have to worry about the storage account limits, which makes managed disk easier to scale out. So, what is unmanaged disk? With unmanaged disk, you are responsible for the storage account that hold the virtual hard disk. You pay for the storage account rates for the amount of space you use. A single storage account has a fixed rate limit of 20,000 IOPS operation per second. This means that a storage account is capable of supporting 40 standard VHDs at full utilization. You can create Azure Virtual Machine either by using Azure Portal, Resource Manager Template, Azure PowerShell, Azure CLI, or programmatic APIs. Let me quickly take you to the Azure Portal to show you how can you create an Azure Virtual Machine using the Azure Portal. I'm on my Azure Portal. Go to the search box and type in Azure Virtual Machine or Virtual Machine, or you can select simply the virtual machine from the gallery. As you can see that I have three virtual machines, and you can notice the status of the virtual machine as stopped or deallocated. So whenever I'm not utilizing or using these servers, I deallocate the server so that it doesn't charge my account. So to create a new virtual machine, click on create and click on new virtual machine. Basic things first, select the subscription. You can either create a resource group or pick an existing resource group. Sorry, give a name for your VM. Pick a region closest to where you want to host it. I'm going to keep it Australia East. There is availability options. We will talk about it more on this later. I'm going to pick no infrastructure required at this time. Security type, I'm going to keep it as standard, which gives me basic level of security for my VMs. Image, you can pick any image from the gallery. There are flavors of Linux and Windows operating system. So I'm going to keep with Ubuntu now. and pick a virtual machine size. There are a lot of available size for this virtual machine. So I'm going to pick a virtual machine with 2 virtual CPUs and 8 gigabytes of memory. And I can decide whether I want to configure with a password or SSH public key. If you want to modify the username or SSH key, you can modify it over here. And if you do want to allow or block any of these inbound ports, you can do that. The next step will allow you to set up a disk. So you can either pick a premium disk, which will give you high performance IOPS, and standard hard disk is low IOPS. And you can pretty much leave the rest of the option to default and click on review and create. And after the validation, you can click on create to create your virtual machine. So if you want to know or learn more about it, please watch my tutorials created for AZ-104. There I have explained in much more granular details on how to connect to a virtual machine, how to configure the networking components, etc. Now let's go back to the presentation. You can create Azure Virtual Machine by using PowerShell as well. So this is a classic example of how you can use the Cloud Shell to create the resource group and a virtual machine. This is another example of using Azure CLI to create a virtual machine. You can download this presentation by going into aguidetocloud.com, and you can go through these commands to create your own Azure virtual machine using CLI or Azure PowerShell. So that concludes this lesson. In the next lesson, we are going to learn about Azure Virtual Machine, and we are going to go a little deep dive into things we haven't discussed so far. In this lesson, we are going to go deep dive into Azure Virtual Machine. And within this lesson, we will learn about how to capture performance diagnostics for a VM, how can you recover a failed virtual machine configuration options, and various sizing considerations. Let us start with understanding how to capture performance diagnostics for a virtual machine. The performance diagnostic tool helps you troubleshoot performance issues that can affect a Windows virtual machine. Supported troubleshooting scenarios include quick check on known issues and best practices, and complex problems that involve slow VM performance or high usage of CPU, disk space, or memory. You can run performance diagnostic directly from the Azure portal, where you can also review insights and a report on various logs, rich configuration, and diagnostic data. Performance Diagnostics installs a virtual machine extension that runs a diagnostic tool that is named Perf Insights. The next one is how can you recover a failed virtual machine by using a rescue virtual machine. So if an Azure virtual machine is inaccessible, it may be necessary to attach the operating system disk to another virtual machine to perform the recovery steps. So let me go to the Azure portal and show you the process on a high level. So I'm on my Azure portal, go to virtual machines, and first of all, you need to stop the failed VM. So assume this is the virtual machine you're having trouble with. Make sure you stop it. So you can stop a virtual machine by going into this ellipsis and click on stop. Or you can go to the main virtual machine overview pane and you can stop it from here as well. After stopping the virtual machine, go to the disk and you can select the disk and you can create a snapshot of the disk. And then you create a new temporary VM, which is known as a rescue VM, and attach the disk what you created using this snapshot to the rescue VM. And then connect to the rescue VM to investigate and mitigate issues with the failed virtual machine OS disk. The next step is to detach the failed VM OS disk from the rescue VM and perform a disk swap to swap the failed VM operating system disk from the rescue VM back to the failed VM. And the last step is to remove the resources that were created for the rescue virtual machine. So now let's look into sizing a virtual machine. We talked about it briefly on the previous lesson. So rather than specifying a processing power, memory, and storage capacity independently, Azure provides different virtual machine sizes that offers variations of these characteristics. The best way to determine the appropriate virtual machine size is to consider the type of workload your virtual machine needs to run. For mostly general purpose, go with D series virtual machines. Let's look into virtual machine configuration options. The size of the virtual machine that you use is determined by the workload that you want to run. The size that you choose then determines factors such as processing power, memory, and storage capacity. Azure offers a wide variety of sizes to support many types of users. Each size provides a range of configuration options to support various workload that may possibly run in Azure. Let's look into the virtual machine categories next. You can design Azure virtual machines for a wide variety of workloads, starting from economical entry level virtual machines to high performance virtual machines for specialized workloads. The first one is entry level virtual machines. These entry level virtual machines are economical, low cost virtual machines for workloads that normally don't use a lot of CPU but occasionally need to burst to handle higher workloads. The next type is burstable. Burstables are designed for workloads that will run for a long period of time by using a small fraction of the allocated CPU performance and then spike to the full power of the CPU due to incoming traffic or required work. The third type and the most commonly used are general purpose. This provides balanced CPU to memory ratio. This is ideal for testing and development, small to medium databases, and low to medium traffic web servers. The next type is compute intensive. So this offers high CPU to memory ratio. These virtual machines are good for medium traffic web servers, network appliances, batch processors, and application servers. Fifth type is memory optimized. Memory optimized virtual machines offer high memory to CPU ratio. These are great for relational database servers, medium to large caches, and in memory analytics. The next one is GPU accelerated. These are specialized virtual machines targeted for heavy graphic rendering and video editing, as well as model training and inferencing with deep learning. These are available with single or multiple GPUs. The seventh type is high performance computing. These virtual machines offer fastest and most powerful CPU virtual machines with optional high throughput network interfaces. And the last type is storage optimized. These virtual machines offer high disk throughput and I/O ideal for big data, SQL, NoSQL databases, data warehousing, and large transactional databases. So rather than specifying processing power, memory, and storage capacity independently, Azure provides different virtual machine sizes that offer variations of these characteristics. The best way to determine the appropriate virtual machine size is to consider the type of workload your virtual machine needs to run. Now let's look into how can you manage the availability of your virtual machines. First of all, what is availability? Availability is the percentage of time a service is available for use. Let's assume you have a website and you want your customers to be able to access information at all times. Your expectation is 100% availability of concerning websites access. Azure virtual machines run on physical servers hosted within the Azure data center. As with most physical devices, there are chances that there could be a failure. If the physical server fails, the virtual machines hosted on the server will also fail. If this happens, Azure will move the virtual machine to a healthy host server automatically. However, the self-healing migration could take several minutes, during which the applications hosted on that virtual machine will not be available. And maintenance even range from software updates to hardware upgrades and are required to improve platform reliability and performance. These events usually are performed without impacting any guest virtual machines, but sometimes the virtual machines will be rebooted to complete an upgrade or update. So let's talk about the high availability and disaster recovery options. First, let's learn about the availability sets. Availability set is a logical grouping of virtual machines within a data center that allows Azure to understand how your application is built to provide for redundancy and availability. Two or more virtual machines should be created within an availability set to provide for a high available application and to meet the 99.95 Azure SLA. An availability set is composed of two additional groupings that protect against hardware failures and allow update to safely apply fault domains and update domains. The next high availability options are availability zones. Availability zones are alternates to availability set and expand the level of control you have over maintaining the availability of the application and data on your virtual machines. An availability zone is a physically separate zone within an Azure region, and there are three availability zones per supported Azure region. Each availability zone has a distinct power source, network, and cooling. By architecting your solutions to use by architecting your solution to use replicated virtual machine in zones, you can protect your apps and data from the loss of a data center. If one zone is compromised, then replicated apps and data are instantly available in another zone. And each Azure region is paired with another region within the same geography, together making a region pair. The next one is region pairs. So each Azure region is paired with another region within the same geography, together making a region pair. This approach allows for the replication of resources such as VM storage across a geography. This should reduce the likelihood of natural disasters, civil unrest, power outages, or physical network outages affecting availability. Next thing you need to understand images in Azure Marketplace. A marketplace image in Azure has following attributes. It has a publisher, the organization that created the image. Examples include Canonical and Microsoft Windows Server. Second one is author, the name of the group of related images created by a publisher. Examples include Ubuntu Server and Microsoft Windows Server. Third is SKU, an instance of an offer, such as a major release of a distribution. Examples include 1804 LTS and 2019 Data Center Edition, etc. And finally, it will include version, the version number of the image SKU. So to identify marketplace image, when you deploy a virtual machine programmatically, supply these values individually as parameters. And please note, images are unique to Azure region and you may find a different list of images in each region. So another important service you need to understand is Azure Shared Image Gallery or SIG. Shared Image Gallery is a service that helps you build structure and organization around your managed images. Shared Image Gallery provides you managed global replication of images, versioning and grouping of images, highly available images with zone redundant storage, sharing across subscription even between Azure AD tenants, and scaling your deployment with image replicas in each region. And the last topic in this lesson is Virtual Machine Serial Console. The Serial Console in Azure Portal provides access to a text-based console for virtual machines. This serial connection connects to the TTY S0 serial port for Linux virtual machine and COM1 serial port for Windows virtual machines. The serial console provides access to the VM independent of the network or operating system state, and the serial console can only be accessed by using the Azure portal. That concludes this lesson. In the next lesson, we are going to learn about Azure Resource Manager templates. In this lesson, we are going to learn about Azure Resource Manager templates. And we will learn about the different terminologies you need to understand about an Azure Resource Manager template. Alright, so let's start with understanding Azure Resource Manager. Azure Resource Manager provides a consistent management layer to perform tasks through Azure Portal, Azure PowerShell, Azure CLI, REST APIs, and client SDKs. All capabilities that are available in the Azure portal are also available through Azure PowerShell, Azure CLI, the REST APIs, and client SDKs. The functionalities initially released through APIs will be represented in the portal within 180 days of initial release. So, to understand the Azure Resource Manager template, we need to understand the terminology. So, let me explain these one by one. The first one is resource. Resource is a manageable item that is available through Azure. Some common resources are a virtual machine, storage account, web application, database, and virtual network. The second one is a resource group. So, resource group is a container that holds related resources for an Azure solution. The resource group can include all the resources for the solution or only those resources that you want to manage as a group. You decide how you want to allocate resources to resource group based on what makes the most sense for your organization. The next one is a resource provider. Resource provider is a service that supplies the resources that you can deploy and manage through Resource Manager. Each resource provider offers operations for working with the resources that are deployed. Some common resource providers are Microsoft Compute, which supplies the virtual machine resource, Microsoft Storage, which supplies the storage account resource, and Microsoft Web, which supplies the resource related to web applications. Another terminology which we need to understand is Resource Manager Template. Resource Manager Template is a JavaScript object notation, which is known as JSON file, that defines one or more resources to deploy to a resource group. It also defines the dependencies between the deployed resources. The template can be used to deploy the resources consistently and repeatedly. The next one is declarative syntax. Declarative syntax is what lets you state, here is what I intended to create, without having to write the sequences of programming commands to create it. The Resource Manager template is an example of declarative syntax. In the file, you define the properties of the infrastructure to deploy to Azure. So let's look at a Resource Manager template deployment example. With Resource Manager, you can create template in JSON format that defines the infrastructure and configuration of your Azure solution. By using a template, you can repeatedly deploy your solution throughout its life cycle and have confidence that your resources are deployed in a consistent state. And when you create a solution from the portal, the solution automatically includes a deployment template. You don't have to create your template from scratch because you can start with the template for your solution and customize it to meet your specific needs. You can also retrieve a template for an existing resource group by either exporting the current state of the resource group. Viewing the exported template is a helpful way to learn about the template syntax. So let me quickly go back to the Azure portal and show you how the resource manager template look like. So one way to easily find out the readily available ARM templates is by going into Azure Quick Start templates. So search for Azure Quick Start templates, and this is where you would be able to find most commonly used and most popular Quick Start templates you can reuse. So let's assume you want to deploy let's assume you want to deploy a configuration manager current branch in Azure. So select that, and it gives you information about what it does and what are the parameters which is defined, And if you want to deploy it via PowerShell or command line, you can see that command over here. And if you want to straight away deploy to Azure, just click on deploy to Azure. Since I logged into the Azure portal on the same browser, it immediately used my login credentials to log into the Azure portal. And it only asks you for certain parameters to select some subscription, where would you like to host it, what's the prefix you want to give, how many number of clients you want to support, configurations, things like that. Once you provide it, this template is going to deploy the SCCM current branch resources within Azure. And as you can see that there are 6 resources. So another way to view is, let's go to GitHub and we can visualize how it is going to look like. So click on visualize and it is going to show me what are the high level components which is going to involve in this whole deployment. And you can click on visualize to see how it is going to look like, including the script which is associated with the whole deployment. If you do want to edit parameters or templates, you can do it right on this, and you can add your own custom code or lines within these template. After you populate all the necessary data which is required for this template, hit on review and create to deploy this whole solution within Azure. So let's look into 3-tier Azure Resource Manager template. So how you define templates and resource group is entirely up to you and how you want to manage your solution. For example, you can deploy your 3-tier application through a single template to a single resource group. For example, in this template, it includes app service, which is associated with an SQL database, and we have a separate resource called virtual machine in the same resource group. The next thing we need to understand about resource manager template is nested resource manager templates. So to deploy complex solutions, you can break your Azure Resource Manager templates into many related templates and then deploy them together through a main template. The related templates can be separate files or template syntax that is embedded within the main template. This following example show how to deploy 3-tier solution through a parent template that includes 3 nested templates. If you envision your tiers having separate lifecycle, you can deploy your 3-tier to separate resource groups. Notice the resources can still be linked to resources in other resource group. And if you want to create a resource manager template, you can create it one for yourself using Azure portal as well. Resource manager templates are JSON files that define the resources that you need to deploy for your solution. You can create a resource template from the settings section for a specific virtual machine by selecting the automation script option. And you can create resource manager templates in Visual Studio Code and use Azure CLI to deploy them as well. So that concludes this lesson. In the next lesson, we are going to learn about Azure Container Instances. In this lesson, we are going to learn about Azure Container Instances. And within this lesson, we will learn about what's the difference between virtualization and containerization. Then we will learn about container images and Docker. Let's start with understanding the difference between virtualization and containers. Containers and VMs each have their uses. In fact, many container deployments uses virtual machines as the host operating system rather than running directly on the hardware, especially when running containers in the cloud. A container is an isolated, lightweight silo for running an application on a host operating system. Containers built on top of a host operating system's kernel, and they contain only apps and some lightweight operating system, APIs, and services that run in user mode. In contrast to containers, virtual machines run complete operating systems, including their own kernels. So let's understand what are container images. A container is a loosely isolated environment that allows us to run software packages. These software packages include the code and all dependencies to run applications quicker and more reliably in most computing environments. These packages are known as container images. A container image becomes the unit for distributing applications. Software containerization is an operating system virtualization method that you can use to deploy and run containers without using a virtual machine. Containers can run on physical hardware, in the cloud, on VMs, and across multiple operating systems. So please note that container image is like a virtual machine image. A container is like a running virtual machine. So what is Docker? Docker is a containerization platform that you can use to develop, ship, and run containers. Docker doesn't use a hypervisor, and you can run it on a desktop or laptop if you are developing and testing applications. The desktop version of Docker supports Linux, Windows, and Mac OS. For production systems, Docker is available for server environments, including many variants of Linux and Windows Server 2016 and newer versions. The Docker platform consists of several components that you can use to build, run, and manage containerized applications. So, before we move forward, we need to understand some terminologies related to Docker. Let's start with understanding what is a container. A container is an instance of a Docker image. It represents the execution of a single application, processes, or service. It consists of the contents of a Docker image, an execution environment, and a standard set of instructions. When scaling a service, you create multiple instances of a container from the same image. Or a batch job can create multiple containers from the same image, passing different parameters to each instance. The next is container image. Container image refers to a package with all the dependencies and information required to create a container. The dependencies include frameworks and the deployment and execution configuration that a container runtime uses. Usually, an image derives from multiple base images that are layers stacked on top of each other to form the container's file system. An image is immutable once it has been created. The next terminology to understand is build. Build refers to the action of building a container image based on the information and context provided by the Docker file, plus additional files in the folder where the image is built. You can build images by using docker build command. The next is pull. Pull refers to the process of downloading a container image from a container registry. What about push? Push refers to the process of uploading a container image to a container registry. The next one is Docker file. Docker file refers to a text file that contains instructions on how to build a Docker image. It's like a batch script. The first line states the base image, followed by instructions to install required programs, copy files, and so on until you get the working environment you need. Last but not the least is registry. Registry is a service that stores container images. For example, the ACR is built on Docker Registry 2.0. This is an example which shows the Docker image command retrieves image by image name, image tag, or by most recent version. So before deploying a container to container instances, use the Docker run command to run it locally and confirm that it works. Now let's talk about ACR, which is Azure Container Registry. Container Registry is a managed Docker registry service based on the open source Docker Registry 2.0. You can create and maintain Azure Container Registries to store and manage your private Docker container images. Use container registries in Azure with your existing container development and deployment pipelines, and use Azure Container Registry Build to build container images in Azure. So let's examine how container repository function in a Docker ecosystem. In the Docker ecosystem, a container registry contains a set of container repositories. Container repositories functions like code source control repositories as they store versionized copies of a container image. A machine running Docker can pull a container image from a registry and create a new container instance from the image. So what about the container registry SKUs? There are primarily three SKUs available. The first one being basic. This is a cost optimized entry point for developers learning about container registry. Basic registries have the same programmatic capabilities as standard and premium. However, there are size and usage constraints. The next one is standard. A standard registry offers the same capabilities as basic but with increased storage limit and image throughput. And standard registries should satisfy the needs of most production scenarios. And the third SKU is premium. Premium registries have higher limits on constraints such as storage and concurrent operations, including enhanced storage capabilities to support high volume scenarios. In addition to high image throughput capacity, Premium adds features like geo-replication for managing a single registry across multiple regions, maintaining a network closed registry to each deployment. So let's examine how a container registry handles the build task. Azure-based container builds are executed by using the AZ-ACR build command. The AZ-ACR build command using the Azure CLI tool receives a context from the local machine, sends the context to Azure Container Registry task, and by default pushes the built image to its registry upon completion. And the code from your local machine will be uploaded to the build server, and then the Docker file will be used in the build process. Now let's learn about Azure Container Instances or ACI. So containers are becoming the preferred way to package, deploy and manage cloud applications. Container instances offer the fastest and simplest way to run a container in Azure without having to manage any virtual machines and without having to adopt a higher level service. Container instances is a good solution for any scenario that can operate in isolated containers, including simple applications, task automation, and build jobs. For scenarios where you need full container orchestration, including service discovery across multiple containers, automatic scaling, and coordinated application upgrades, Microsoft recommend Azure Kubernetes Service or AKS. So let's examine the role of container group in container instances. Container group is the top level resource in container instances. A container group is a collection of containers that get scheduled on the same host machine. The containers in a container group share a lifecycle, resources, local network, and storage volumes. So let's finish off this lesson by understanding the container instances features. The first one is fast startup times. Containers offer significant startup benefits over virtual machines. Container instances can start containers in Azure in seconds without the need to provision and manage virtual machines. Second feature is public IP connectivity and DNS name. Container instances enable exposing your containers directly to the internet with an IP address and a fully qualified domain name. When you create a container instance, you can specify a custom DNS name label so your application is reachable at customlabel.azureregion.azurecontainer.io. Another feature is hypervisor level security. Historically, containers have offered application dependency isolation and resource governance, but have not been considered sufficiently hardened for hostile multi-tenant usage. Container instances guarantees your application as isolated in a container as it would be in a virtual machine. Another feature is custom sizes. As demand for resource increases, the nodes of an AKS cluster can be scaled out to match. If resource demand drops, nodes can be removed by scaling in the cluster. AKS scale operations can be completed using the Azure portal or the Azure CLI. The next feature is persistent storage. To retrieve and persist state with container instances, Microsoft offers direct mounting of Azure file shares. The next feature is Linux and Windows containers. Container instances can schedule both Windows and Linux containers with the same API. Simply specify the operating system type when you create your container groups. Some features are currently restricted to Linux containers. While Microsoft worked to bring feature parity to Windows containers, you can find current platform differences in quotas and region availability for container instances. Another feature is co-scheduled groups. Container instances support scheduling of multi-container groups that share a host name, local network, storage, and lifecycle. This enables you to combine your main application container with other supporting role containers such as logging sidecars. And the last feature is virtual network deployment. Container instances enables deployment of container instances into an Azure virtual network. By deploying container instances into a subnet within your virtual network, they can communicate securely with other resources in the virtual network, including those that are on-premises through VPN gateway or express route. That concludes this lesson. In the next lesson, we are going to learn about Microsoft Identity Platform. In this lesson, we are going to learn about Microsoft Identity Platform, and within this lesson we will go deep into Azure Active Directory and Active Directory Authentication Library. Let's understand what does it mean by identity as the control plane. Your cloud identity connects you to a wide variety of enterprise services both within your organization and outside of your organization. Identities are the new control plane, and securing them beyond just a password is a priority among many organizations. If an identity is stolen, the person or even the company is at risk for losing precious personal information and intellectual property. This can have devastating financial implications that are difficult to recover from. Microsoft Azure Active Directory or Azure AD is Microsoft's cloud-based identity and access management service. Azure AD creates and manages credentials that help enterprise users sign in and access both internal and external resources that are offered by your company or third-party companies more securely. Azure Active Directory's geographically distributed architecture combines extensive monitoring, automated rerouting, failover, and recovery capabilities which deliver company-wide availability and performance to customers. I have created multiple Azure Active Directory deep down in my previous sessions. If you want to go through each and every components within an Azure Active Directory, please watch my AZ-104 playlist or AZ-500 training playlist. Let us understand what is Active Directory Authentication Library or ADAL. For clients that need to access protected resources, Azure AD provides the Active Directory Authentication Library. ADAL version 1.0 enables application developers to authenticate users to cloud or on-premises Active Directory and obtain tokens for securing API calls. ADAL makes authentication easier for developers through features such as configurable token cache that stores access tokens and refresh tokens, automatic token refresh when an access token expires and a refresh token is available, and support for asynchronous method calls. So let's look at how to create an authentication context by using ADAL. First, you initialize your app's authentication context, which is ADAL's primary class. Authentication context is where you pass ADAL that coordinates its needs to communicate with Azure AD and tell it how to cache tokens. The basic principle behind ADAL is that whenever your app needs an access token, your app simply calls auth context.acquire token async and ADAL does the rest. And when your app requests token by calling acquire token async, ADL will attempt to return a token without asking the user for credentials. If ADL determines that the user need to sign in to get a token, it will display a login dialog, collect the user's credentials, and return a token upon successful authentication. If ADAL is unable to return a token for any reason, it will throw an ADAL exception. Let us look into an Azure AD evolution. Until recently, most developers have worked with Azure Active Directory version 1.0 platform to authenticate work and school accounts by requesting token from Azure AD version 1.0 endpoint by using ADAL, Azure Portal for application registration and configuration, and Azure AD Graph API for programmatic application configuration. With Microsoft Identity Platform version 2.0, you can expand your reach to these kinds of users, the users which are work and school accounts, personal accounts, your customers who bring their own email and social identity, such as LinkedIn, Facebook, Google, via the Azure AD B2C offering. With the unified Microsoft Identity Platform, you can write code once and authenticate any Microsoft identity into your application. For several platforms, there is a fully supported open source library called Microsoft Authentication Library or MSAL. You can use the Azure portal to register and configure your application and use the Microsoft Graph API for programmatic application configuration. So let us now look into Microsoft Identity Platform. Microsoft Identity Platform is an evolution of Azure AD Developer Platform. It allows developers to build applications that log in users, get tokens to call APIs such as Microsoft Graph or APIs that developers have built, and it consists of an authentication service, open source libraries, application registration and configuration through a developer portal and application API, full developer documentation, quick start samples, code samples, tutorials, how-to guide, and other developer content. The Microsoft Identity Platform supports industry standard protocols such as Open Authentication 2.0 and OpenID Connect. Let's understand the objects in Azure AD. An Azure AD application is defined by its one and only application object, which resides in Azure AD tenant where the application was registered. To access resources that are secured by an Azure AD tenant, the entity that requires access must be represented by a security principal. This is true for both users and application. The security principal defines the access policy and permissions for the user or application in the Azure AD tenant. This enables core features such as authentication of the user or application during sign-in and authorization during resource access. Note that registering an application is a necessary step which involves telling Azure AD about application, including the URL where it's located, the URL to send replies after authentication, and uniform resource identifier to identify the application. Azure AD needs to communicate with the application when handling sign-in or exchanging tokens. Some additional considerations exist when developing a multi-tenant application instead of a single tenant application. In particular, if you are making an application available to users in multiple directories, you need a mechanism to determine which tenant they are in. To accomplish this task, Azure AD provides a common authentication endpoint where any multi-tenant application can direct sign-in requests instead of a tenant-specific endpoint. This endpoint is https login.microsoftonline.com/common. For all directories in Azure AD, while a tenant-specific endpoint might be https login microsoft.online.com/contoso.onmicrosoft.com. The common endpoint is especially important to consider when developing your application because you will need the necessary logic to handle multiple tenants during sign-in, sign-out, and token validation. That concludes this lesson. In the next lesson, we are going to learn about Microsoft Graph. In this lesson, we are going to learn about Microsoft Graph, and we will go deep into Microsoft Graph data and services, Graph Explorer, and Graph SDKs. Microsoft Graph is fully replacing Azure Active Directory Graph. For more production apps, Microsoft Graph can already fully support Azure AD scenarios. In addition, Microsoft Graph supports many new Azure AD datasets and features that are not available in Azure AD Graph. The Microsoft Graph API offers a single endpoint, which is graph.microsoft.com, to provide access to rich, people-centric data and insights exposed as resources of Microsoft 365 services. You can use REST APIs or SDKs to access the endpoint and build apps that support scenarios spanning across productivity, collaboration, education, security, identity, access, device management, and much more. Microsoft Graph Data Connect provides a set of tools to streamline secure and scalable delivery of Microsoft Graph data to popular Azure data stores. This cached data serves as data sources for Azure development tools that you can use to build intelligent applications. You can use the Graph Explorer by going into graph.microsoft.com and quickly test requests directly in the browser. You can use variety of accounts to connect and use the graph data. You can use a commercial account or a consumer account like Outlook, or if you have your own domain, you can use that email address as well. Let's look at the Microsoft Graph SDK supports. The Microsoft Graph client is designed to make it simple to make calls to Microsoft Graph. The SDK to interact with Microsoft Graph using easy to parse classes and properties, and it is available on NuGet as well. So let's look into Microsoft Graph Authentication SDK. The service library contains models and request builders that are generated from Microsoft Graph metadata to provide a rich, strongly typed, and discoverable experience when working with the many datasets that are available in Microsoft Graph. The core library provides a set of features that enhance working with all Microsoft Graph services. The features include embedded support for retry handling, secure redirects, transparent authentication, and payload compression, which improve the quality of your application's interactions with Microsoft Graph. These features don't add complexity and give you enhanced control of your application. The core library also provides support for common tasks such as paging through collections and creating batch requests. So how can you create authentication provider? The authentication provider classes are a special helper classes that implement most of the logic that's usually implemented by using MSAL. To use the Microsoft Graph SDK, you will need to create an authentication provider instance to use as a parameter for the Graph client class. So what are the available authentication providers? Authentication providers implement the code required to acquire a token using MSAL, and this can handle a number of potential errors for cases like incremental consent, expired passwords, and conditional access, and then set the HTTP request authorization header. And this table describes the set of providers available in the library. The device code flow allows users to sign into the device by using another device. With this provider, you only need to provide a client ID and authority. The integrated Windows flow allows Windows computers to silently acquire an access token when they are domain joined. With this provider, you only need to provide a client ID and authority. And the Microsoft Graph client simplifies making calls to Microsoft Graph. You can use single client instance for the lifetime of the application. This code example show you how to create an instance of a Microsoft Graph client with an authentication provider. The authentication provider will handle acquiring access token for the application. After the client is created, you can use the me property to make a request to the associated endpoint. That concludes this lesson. In the next lesson, we are going to learn about Azure Key Vault. In this lesson, we are going to learn about Azure Key Vault. Microsoft Azure Key Vault is a cloud service that works as security enhanced secret store. Key Vault allows you to create multiple security enhanced containers called vaults. These vaults are backed by hardware security modules or known as HSMs. Vaults helps to reduce the chance of accidentally losing security information by centralizing the storage of application secrets. Vaults also control and log the access to anything stored in them. Azure Key Vault is designed to support any type of secret such as a password, database credential, API key, or certificate. Software or HSM can help to protect these secrets. Azure Key Vault can also handle requesting and renewing TLS certificates, providing the features required for a robust certificate lifecycle management solution. Let's understand some of the Key Vault concepts. First, let's look into vault. A vault is a logical group of secrets. A vault owner can create a key vault and gain full access and control over it. And the vault owner can also set up auditing to log who accesses secrets and keys. And administrators can control the key lifecycle. And then there is vault consumer. A vault consumer can perform actions on the assets inside the key vault when the vault owner grants the consumer access. The available actions depend on the permissions granted. So how do you perform authentication in Key Vault? So to perform any operations with Key Vault, you first need to authenticate to it. So there are primarily three ways to access it or authenticate it. The first one is using managed identity, then service principal and certificate, and then service principal and secret. So let's look into managed identity first. So when you deploy an app on a virtual machine in Azure, you can assign an identity to your virtual machine that has access to Key Vault. You can also assign identities to other Azure resources. The benefit of this approach is that the app or service isn't managing the rotation of the first secret. Azure automatically rotates the identity. Microsoft recommends this approach as a best practice. Now let's look into service principal. First, service principal and certificate. So you can use service principal and an associate certificate that has access to Key Vault. Microsoft don't recommend this approach because the application owner or the developer must rotate the certificate. The second option is service principal with a secret. Although you can use service principal and a secret to authenticate to Key Vault, Microsoft don't recommend this either. It's hard to automatically rotate the bootstrap secret that's used to authenticate to Key Vault. Now let's look into Key Vault secret types. Key Vault enabled Azure applications and users to store and use several types of secret key data, including cryptographic keys, secrets, certificates, and Azure storage. First, look into cryptographic keys. Key Vault supports multiple key types and algorithms and using hardware security modules for high value keys. Let's look into secrets. Key Vaults provide secure storage for secrets such as passwords and database connection strings. What about certificates? Key Vault supports certificates, which are built on top of keys and secrets and add an automated renewal feature. And Azure Storage Key Vault can manage the keys of an Azure storage account. Internally, Key Vault can list keys with an Azure storage account and regenerate the keys periodically. This simple script demonstrates how you can create a resource group and Azure Key Vault resource by using Azure CLI. Once created, the script creates and then retrieves a secret named database password in the Key Vault resource. Key Vault provides a way to securely store credentials and other keys and secrets. However, your code needs to authenticate to Key Vault to retrieve them. You can use a security token that you generate and pass it on to the constructor of the Key Vault client access class. After you have a client instance, you can use getSecretAsync method to retrieve a secret by using unique URI and then retrieve the value of the secrets from the bundle. That concludes this lesson. In the next lesson, we are going to learn about Azure Managed Identities. In this lesson, we are going to learn about Azure Managed Identities. Let us start with understanding Azure AD Managed Identity. A common challenge when building cloud application is managing the credentials in your code for authenticating to cloud services. Keeping the credentials secure is an important task. Ideally, the credentials never appear on developer workstations and aren't checked into source control. Azure Key Vault provides a way to securely store credentials, secrets, and other keys, but your code must authenticate to Key Vault to retrieve them. The Managed Service Identities or MSI feature in Azure Active Directory solves this problem. This feature provides Azure services with an automatically managed identity in Azure AD. You can use the identity to authenticate to any service that supports Azure AD authentication, including Key Vault, without providing any credentials in your code. This diagram illustrates how a managed identity works with an Azure virtual machine. First, Azure Resource Manager receives a request to enable the system assigned managed identity on a virtual machine or create a user assigned managed identity and assign it to a virtual machine. Then the Azure Resource Manager creates a service principal in the Azure AD for the virtual machine identity. The service principal is created in the Azure AD tenant that's trusted by the subscription. Then the Azure Resource Manager configures the identity on the virtual machine. It updates the Azure Instance metadata service identity endpoint with the service principal client ID and certificate. After the VM has an identity, use the service principal information to grant the virtual machine access to Azure resources. To call Azure Resource Manager, use role-based access control in Azure AD to assign the appropriate role to the virtual machine service principal. Then your code that's running on the VM can request a token from two endpoints that are accessible only from within the virtual machine. Then your code makes a call to Azure AD to request an access token. And your code sends the access token on the call to a service that supports Azure AD authentication. You can enable a system assigned managed identity directly on the Azure Service instance. Azure creates an identity for the instance in the Azure AD tenant that's trusted by the subscription of the instance. Credentials are provisioned onto the instance after the identity is created. The lifecycle of a system assigned identity is directly linked to the Azure Service instance that it's enabled on. Azure automatically deletes the credentials and the identity in Azure AD when the instance is deleted. An Azure standalone resource can create a user assigned managed identity. Through a create process, Azure creates an identity in the Azure AD tenant that's trusted by the subscription in use. After the identity is created, you can assign the identity to one or more Azure service instances. and Azure manages the lifecycle of a user-assigned identity separately from the lifecycle of Azure Service instance to which it's assigned. So what are the types of managed identities? Internally, managed identities are service principals of a special type, which are locked and are only be used with Azure resources. When the managed identity is deleted, the corresponding service principal is automatically removed. This table highlights some of the key differences between the two types of managed identities: system assigned and user assigned. So, what are the use cases for managed identities? Your code can use a managed identity to request access token for services that support Azure AD authentication. Azure takes care of rolling the credentials that are used by the service instance. First, create a web application by using Azure CLI. Next, run the identity assign command to create the identity for this application. When creating a container instance by using Azure CLI, you can specify whether to create a system assigned managed identity along with the resource. Alternately, a container that was created by using Azure CLI can use a user assigned managed identity that was created ahead of time. That concludes this lesson. In the next lesson, we are going to learn about API management. In this lesson, we are going to learn about API management in Azure. Let's talk about APIM or API management. API management helps organizations publish APIs to external, partner, and internal developers to unlock the potential of their data and services. Businesses everywhere are seeking to extend their operations as a digital platform, creating new channels, finding new customers, and driving deeper engagement with existing ones. API management provides the core competencies to ensure a successful API program through developer engagement, business insights, analytics, security, and protection. You can use Azure API management to take any backend and launch a full-fledged API program based on it. So let's understand some of the terminologies related to APIs or API management. The first one is backend API. A backend API is an HTTP service that implements your API and its operations. Second terminology is front-end API. Front-end API or APIM API does not host APIs. It creates facets for your APIs to customize the facet according to your needs without touching the backend API. Then there is APIM product. A product contains one or more APIs as well as usage quota and the terms of use. You can include several APIs and offer them to developers through the developer portal. And then we have APIM API operation. Each APIM API represents a set of operations available to developers. Each APIM API contains a reference to the backend service that implements the API and its operations map to the operations implemented by the backend service. The next one is version. Sometimes you want to publish new or different API features to some users, while others want to remain with API that's currently works for them. The next terminology we're going to learn is revision. When your API is ready to go and starts to be used by developers, you usually need to take care in making changes to that API and at the same time not to disrupt callers for your API. It's also useful to let developers know about changes you made. The next one is developer portal. Your customers or developers should use the developer portal to access your APIs. The developer portal can be customized. Now let's learn about products. Products are associations of one or more APIs. Products are associations of one or more APIs. You can include a number of APIs and offer them to developers through the developer portal. You can add an existing API during the product creation, and you can add an API to the product later, either from the product settings page or while creating an API. Developers must first subscribe to a product to get access to the API. When they subscribe, they get a subscription key that is good for any API in that product. If you created the APIM instance, you are an administrator already. So you are subscribed to every product by default. Each API can be added to one or more products. To use an API, developers subscribe to a product that contains that API, which will get them a key to access the API. Products are the means by which developers access APIs. Products in API management have one or more APIs. Developers configure the products with the title, description, and terms of use. And products can be open or protected. You must subscribe to protected products before you can use them. However, you can use open products without a subscription. Let's look into APIs and operations. To use API management, administrators create APIs. Each API consists of one or more operations, and each API represents a set of operations that are available to developers. To use an API, developers can call the API's operation. Each API's operations map to the operations implemented by the backend service. Operations in API management are highly configurable, providing control over URL mapping, query and path parameters, request and response content, and operation response caching. You can also implement rate limit, quotas, and IP restriction policies at the API or individual operation level. And APIs are the foundation of the API management service instance. Each API contains a reference to the backend service that implements the API. That concludes this lesson. In the next lesson, we are going to learn about Event Grid. In this lesson, we are going to learn about Azure Event Grid. In an event-driven architecture, events are delivered in nearly real time so that consumers can respond immediately to events as they occur. An event-driven architecture can use a pub-sub model or an event stream model. On the consumer side, there are some common variations. Single event processing, which means an event immediately triggers an action in the consumer. For example, you could use Microsoft Azure functions with a service bus trigger so that a function executes whenever a message is published to a service bus topic. Other variation is complex event processing. In this scenario, a consumer processes a series of events, observing pattern in the event data by using a technology such as Azure Stream Analytics or Apache Storm. The third variation is event stream processing. In this scenario, you can use a data streaming platform such as an Azure IoT Hub or Apache Kafka as a pipeline to ingest events and feed them to stream processors. The stream processors act to process or transform the stream. In this logical diagram, each type of consumer is shown as a single box. In practice, it's common to have multiple instances of a consumer. To avoid having the consumer become a single point of failure in system, multiple instances might also be necessary to handle the volume and frequency of events. Also, a single consumer might process events on multiple threads. This can create challenges if events must be processed in order or require exactly one semantics. So what is Azure Event Grid? Azure Event Grid allows you to easily build applications with event-based architectures. First, select the Azure resource that you would like to subscribe to and then provide the event handler or webhook endpoint to send the event to. Event Grid has built-in support for events coming from Azure services like storage blobs and resource groups. Event Grid also has support for your own events using custom topics. You can use filters to route specific events to different endpoints, multicast to multiple endpoints, and make sure your events are reliably delivered. These are the Azure services which can send events to Event Grid. Let's look into the sources and handlers. First, let's understand sources. An event source is where the event happens. Several Azure services are automatically configured to send events. You can also create custom application that sends events. Custom applications don't need to be hosted in Azure to use Event Grid for event distribution. Now let's learn about event handlers. An event handler is the place where the event is sent. The handler takes some further action to process the event. Several Azure services are automatically configured to handle events. You can also use any webhook for handling events. The webhook doesn't need to be hosted in Azure to handle events. Event Grid only supports HTTPS webhook endpoints. Let us learn about some Event Grid concepts. The first concept is events. An event is the smallest amount of information that fully describes something that happened in the system. Every event has common information, such as a source of the event, time of the event took place, and a unique identifier. Each event is limited to 64 kilobytes of data. The next concept is event sources. An event source is where the event happens. Each event source is related to one or more event types. Next one is topics. The event grid topic provides an endpoint where the source sent events. The publisher creates the event grid topic and decides whether an event source need one topic or more than one topic. Another concept is event subscriptions. A subscription tells Event Grid which event on topic you are interested in receiving. When creating the subscription, you provide an endpoint for handling the event. The next topic is event handlers. From an Event Grid perspective, an event handler is the place where the event is sent. The handler takes some further action to process the event. Event Grid supports several handler types. You can use a supported Azure service or your own webhook as the handler. An event source is where the event happens, so several Azure services are automatically configured to send events. And the event grid topic provides an endpoint where the source sends events. An event handler is the place where the event is sent at the end. The handler takes some further action to process the event. So let's look at a schema. Events consist of set of 5 required string properties and a required data object. The properties are common to all events from any publisher. This code example shows the specific implementation of an event related to Azure Blob storage. All events have the same top-level data. For custom topics, the event publisher determines the data object. The top-level data should have the same fields as standard resource-defined events. So now let's look into the security part of Event Hub. There are 3 types of authentication you can use. The first one is webhook event delivery. Webhooks are one of the many ways to receive events from Azure Event Grid. When a new event is ready, Event Grid service posts an HTTP request to the configured endpoint with the event in the request body. The next is event subscriptions. To subscribe to an event, you must prove that you have access to the event source and handler. And the third type is custom topic publishing. Custom topics use either shared access signature or key authentication. Microsoft recommends shared access signature. So let's look into filtering on Event Hub. By default, all event types for the event source are sent to the endpoint. You can decide to send only certain event types to your endpoint. For example, you can get notified of updates to your resources but not notified for other operations like deletions. In that case, filter by the Microsoft resource write success event type and provide an array with the event type or specify all to get all event types for the event source. And finally, let's learn about event domains. An event domain is a management tool for large number of event grid topics that are related to the same application. You can think of it as the meta topic that can have thousands of individual topics. Event domain allows you to model contoso construction machinery as a single event entity. Each of your customers is represented as a topic within the domain. Authorization and authentication are handled by using Azure Active Directory, and each of your customers can subscribe to their topic and get their event delivered to them. Managed access through the event domain ensures that they can only access their topic. That concludes this lesson. In the next lesson, we are going to learn about event hubs. In this lesson, we are going to learn about Azure Event Hubs. Azure Event Hubs is a scalable event processing service that ingests and processes large volumes of events and data with low latency and high reliability. Azure Event Hub contains these key components: event producers, partitions, consumer groups, throughput units, and event receivers. We will learn about this in this lesson. First, let's look into publishing events. Event Hub's throughput is scaled by using partitions and throughput unit allocations. It is a best practice for publishers to remain unaware of the specific partitioning model chosen for an event hub and to only specify a partition key that is used to consistently assign related events to the same partition. A partition is an ordered sequence of events that is held in an event hub. As newer events arrive, they are added to the end of the sequence. A partition can be thought of as a commit log. Event hubs retain data for a configured retention time that applies across all partitions in the event hub. So, what are consumer groups? The publish subscribe mechanism of Event Hub is enabled through consumer groups. A consumer group is a view which includes state, position, or offset of an entire event hub. Consumer groups enable multiple consuming applications to each have a separate view of the event stream and to read the stream independently at their own pace and with their own offsets. So what is Event Hub's capture? Event Hub's capture enable you to specify your own Azure Blob storage account and container or Azure Data Lake Store account, which are used to store the captured data. These accounts can be in the same region as your Event Hub or in another region, adding to the flexibility of the Event Hub's capture feature. Capture data is written in Apache Avro format. This is a compact, fast binary format that provides rich data structures with inline schema. So how does the integration with Kafka work? You can start using Kafka endpoint from your applications with no code changes and only minimal configuration. You update the connection string in the configuration to point to the Kafka endpoint that is exposed by the Event Hub instead of pointing to the Kafka cluster. Then you can start streaming events from your application that use the Kafka protocol into Event Hubs. Event Hub is a cloud service similar to Blob storage. There is no servers or networks to manage and no brokers to configure. You create a namespace, which is an FQDN in which your topics live, and then create event hubs or topics within that namespace. As a cloud service, Event Hub uses a single stable virtual IP address as the endpoint. Therefore, clients don't need to know about the brokers or machines within a cluster. Let us look into the Event Hub security model. The Event Hub security model is based on a combination of SaaS tokens and event publishers. An event publisher defines a virtual endpoint for an event hub. The publisher can only be used to send messages to an event hub. It is not possible to receive messages from a publisher. Typically, an event hub employs one publisher per client. All messages that are sent to any of these publishers of an event hub are enquired within the event hub. Publishers enable fine-grained access control and throttling. When creating an event hub's namespace, the service automatically generates a 256-bit SAS key named root manage shared access key. This rule has an associated pair of primary and secondary key that grant send, listen, and manage rights to the namespace. You can also create additional keys. It is recommended that you produce a key that grants send permissions to the specific event hub. This code example creates a send only key when creating the event hub. A resource group is a logical collection of Azure resources. All resources are deployed and managed in the resource group, and an event hub namespace provides a unique scoping container referenced by its FQDN, in which you create one or more event hubs. You can use AZ event hubs event hub create command to create a new event hub. Familiarity with these PowerShell and Azure CLI commands is going to be useful for you when you sit for the examination. That concludes this lesson. In the next lesson, we are going to learn about Azure Service Bus. In this lesson, we are going to learn about Azure Service Bus. Each of the messaging services that are used in the cloud have distinct use cases. Storage queues and Event Grid are both serverless services that are ideal for both simple and scaled out workloads that don't have serious ordering or consistency requirements. If a workload doesn't have strict requirements around consistency and order, the Service Bus service offers a more expensive and complex alternative. Event Hub service is unique in that it's designed for streaming data that's need to remain consistent across multiple consumers. So what is Azure Service Bus? Azure Service Bus is a fully managed enterprise integration message broker. Service Bus is most commonly used to decouple applications and services from each other and is a reliable and secure platform for asynchronous data and state transfer. Data is transferred between different applications and services by using messages. A message is in binary format, which can contain JSON, XML, or just text. A namespace is a scoping container for all messaging components. So multiple queues and topics can resolve within a single namespace. And namespaces often serve as application containers. Some of the most common messaging scenarios are messaging, decouple applications, topics and subscriptions, and message sessions. So let us compare events versus messaging services. An event is a lightweight notification of a condition or a state change. The publisher of the event has no expectation about how the event is handled. The consumer of the event decide what to do with the notification. Events can be discrete units or part of a series. A message is a raw data produced by a service to be consumed or stored elsewhere. The message contains the data that triggered the message pipeline. The publisher of the message has an expectation about how the consumer handles this message. A contract exists between these two sides. For example, the publisher sends a message with the raw data and expects the consumer to create a file from that data and send a resource when the work is done. Let's learn about queues. Queues offer first in first out message delivery to one or more competing consumers. That is, receivers typically receive and processes messages in the order in which they are added to the queue. and only one message consumer receives and processes each message. A key benefit of using queues is to achieve temporal decoupling of application components. In other words, the producers and consumers do not have to be sending and receiving message at the same time because messages are stored durably in the queue. Furthermore, the producer does not have to wait for a reply from consumer in order to continue to process and send messages. So you can use a queue that acts as a buffer between a task and service it invokes to smooth intermittent heavy loads that can cause the service to fail or task to time out. This can help to minimize the impact of peaks in demand on availability and responsiveness for both the task and the service. In contrast to queues, in which each message is processed by a single consumer, topics and subscriptions provide a one-to-many form of communication. Messages are sent to a topic and delivered to one or more associated subscriptions, depending on filter rules that can be set on a per subscription basis. And the subscription can use additional filters to restrict the message that they want to receive. Now let's look into messages, payloads, and serialization. Messages carry a payload and metadata in the form of key value pair properties describing the payload and giving handling instruction to the service bus and applications. When in transit or stored inside of service bus, the payload is always an opaque binary block. The content type property enables applications to describe the payload. When using the legacy Simple Network Management Protocol or SBMP, those objects are then serialized with the default binary serializer or with a serializer that is externally supplied. That concludes this lesson. In the next lesson, we are going to learn about Azure Queue Storage. In this lesson, we are going to learn about Azure Queue Storage. Azure Queue Storage is a service for storing large numbers of messages that can be accessed from anywhere in the world via authenticated calls using HTTP or HTTPS. A single queue message can be up to 64 kilobytes in size, and a queue can contain millions of messages up to the total capacity limit of a storage account. Let us look into the components involved in an Azure Queue Storage. The first one is URL format. Queues are addressed by using following URL format. It starts with https storage account queue.co.windows.net and the queue name. The following URL addresses a queue in the diagram: http myaccount.queue.co.windows.net / images to download or images to resize. The second component is storage account. All access to Azure storage is done through a storage account. The third component is queue. A queue contains a set of messages. All messages must be in a queue. Note that the queue name must be all lowercase. And we have a message. A message can be in any format up to 64 kilobyte. The maximum time that a message can remain in the queue is 7 days. Let's look at a code example. The Azure Storage Client Library for .NET supports using a storage connection string to configure endpoints and credentials for accessing storage services. The best way to maintain your storage connection string is in a configuration file. To configure your connection string, open the application configuration file in the Microsoft Visual Studio and add a new element to the app settings section. The queue client class enables you to retrieve queues stored in queue storage. To insert a message into an existing queue, call the send message method. A message can be either a string or a byte array. You can peek at the message in the front of the queue without removing it from the queue by calling the peek messages method. And you can get an estimate of the number of messages in the queue. The getProperties method returns queue properties including the message count. The approximate message count property contains the approximate number of messages in the queue. And this number is not lower than the actual number of messages in the queue, but could be higher. When you call the receive messages, you can get the next message in a queue. A message returned from the receive messages become invisible to any other code reading messages from this queue. That concludes this lesson. In the next lesson, we are going to learn about monitoring in Azure. In this lesson, we are going to learn about monitoring in Azure. Azure Monitor maximizes the availability and performance of your application by delivering a comprehensive solution for collecting, analyzing, and acting on telemetry from your cloud and on-premises environments. It helps you understand how your applications are performing and proactively identifies issues affecting them and the resources they depend on. You can consider Azure Monitor a single pane of glass that was once handled by multiple separate services. Using the insights and metrics, you can then implement workloads to integrate with popular tooling in the market. This following diagram gives a high-level view of Azure Monitor. At the center of the diagram are the data stores for metrics and logs, which are the two fundamental types of data used by Azure Monitor. On the left are the sources of monitoring data that populate these data stores. And on the right are the different functions that Azure Monitor performs with this collected data, such as analysis, alerting, and streaming to external systems. All data collected by Azure Monitor fits into one of two fundamental types: logs and metrics. Logs contain different kind of data organized into records with different sets of properties for each type. Telemetry such as events and traces are stored as logs in addition to performance data so that it can all be combined for analysis. Metrics are numerical values that describe some aspect of a system at a particular point in time. They are lightweight and capable of supporting near real-time scenarios. Log data collected by Azure Monitor is stored in log analytics, which includes a rich query language to quickly retrieve, consolidate, and analyze collected data. You can create and test queries by using the log analytics page in the Azure portal and then either directly analyze the data by using these tools or save queries for use with visualizations or alert rules. Let's look into alerts. Alerts proactively notifies you when important conditions are found in your monitoring data. They allows you to identify and addresses issues before the users of the system notice them. Please note that the new unified alert experience in Azure Monitor now includes log analytics and application insights. The previous alert experience and alert types are called classic alerts. Alert rule captures the target and criteria for alerting. The alert rule can be in an enabled or disabled state, and alerts only fire when enabled. Let's look at alert state. You can set the state of the alert to specify where it is in the resolution process. When the criteria specified in the alert rule is met, an alert is created or fired, and it has a status of new. You can change the status when you acknowledge an alert and when you close it. All state changes are stored in the history of the alert. Alert state is different and independent of the monitor condition. Alert state is set by the user. Monitor condition is set by the system. When an alert fires, the alert's monitor condition is set to be fired. When the underlying condition that caused the alert to fire clears, the monitor condition is set to resolved. So the alert state isn't changed until the user changes it. Let's look into Application Insights. Application Insights is a feature of Azure Monitor and is an extensible application performance management service for developers and DevOps professionals. You can use it to monitor live applications as it is designed to help continually improve performance and usability of live applications. Application Insight will automatically detect performance anomalies. It includes powerful analytics tools to help diagnose issues and to understand what users actually do with an application. Let's look into an application insight architecture. You install a small instrumentation package in your application and set up an application insight resource in the Microsoft Azure portal. The instrumentation monitor your application and sends telemetry data to the portal. You can instrument not only the web service application but also any background component and the JavaScript in the web pages themselves. In addition, you can pull in telemetry from the host environment such as performance counters, Azure Diagnostic, or Docker logs. You can also set up web tests that periodically sends synthetic requests to your web services. All the telemetry streams are integrated in the Azure portal, where you can apply powerful analytic and search tools to the raw data. So what does the Azure Monitor collect? Azure Monitor can collect data from a variety of sources. Let's look into each of these one by one. The first one is application monitoring data. This includes data about the performance and functionality of the code you have written, regardless of its platform. The next one is guest operating system monitoring data. This includes data about the operating systems on which your application is running. This could be running in Azure, another cloud, or on premises. Third is Azure resource monitoring data. This includes data about the operation of an Azure resource. The fourth one is Azure subscription monitoring data. This includes data about the operation and management of an Azure subscription as well as data about the health and operation of Azure itself. The fifth one is Azure tenant monitoring data. This includes data about the operation of the tenant level Azure services such as Azure Active Directory. Monitoring data in Azure comes from a variety of sources that can be originated into tiers. The highest tiers being your application and any operating systems, and the lower tier being components of Azure platform. All data collected by Azure Monitor fits into one of two fundamental types: metrics or logs. Metrics are numerical values that describe some aspect of a system at a particular point in time. They are lightweight and capable of supporting near real-time scenarios. Logs contain different kind of data organized into records with different sets of properties for each type. Telemetry such as events and traces are stored as logs in addition to performance data so that it can all be combined for analysis. Let's look into application map. Application map helps you spot performance bottleneck or failure hotspots across all components of your distributed application. Each node on the map represents an application component or its dependencies and has health KPI and alert status. You can select through from any component to more detailed diagnostic such as application insight events. If your app uses Azure services, you can also select through the Azure diagnostic such as SQL database advisor recommendations. That concludes this lesson. In the next lesson, we are going to learn about Azure CDN. In this lesson, we are going to learn about Azure CDN, which is Azure Content Delivery Network. So what is a CDN? A content delivery network is a distributed network of servers that can efficiently deliver web content to users. CDNs store cached content on edge servers that are close to users to minimize latency. These edge servers are located in point of presence locations, which is known as POP locations, that are distributed throughout the globe. A CDN delivers content through a network of servers that are closest to the end users. Without a CDN, content delivery suffers, yielding a poor customer experience because of routing complications, traffic, and congestion. Many customers might feel that CDN isn't worth the extra effort. They want to avoid multi year contracts and added complexities. Let's discuss typical CDN uses. The first one is delivering static resources, often from a website for client applications. These resources can be images, style sheets, documents, files, client side scripts, HTML pages, HTML fragments, or any other content that the server doesn't need to modify for each request. The second one is delivering public, static, and shared content to devices such as mobile phones and tablets. Another use would be serving entire websites that consist of only public static content to clients without requiring any dedicated compute resources. Another common use is streaming video files to client devices on demand, taking advantage of the low latency and reliable connectivity available from the globally located data centers that offers CDN connections. Another use case is supporting Internet of Things solutions. The huge number of devices and appliances involved in an IoT solution can easily overwhelm an application if it has to distribute firmware updates directly to each device. And copying with peaks and surges in demand without requiring the application to scale, avoiding the consequent increased running cost. CDNs are typically used to deliver static content such as images, style sheets, documents, client-side scripts, and HTML pages. The major advantage of using a CDN are lower latency and faster delivery of content to users, regardless of their geographical location in relation to the data center where the application is hosted. And CDNs can also help to reduce the load on the web application because the application does not have to serve requests for the content that is hosted in the CDN. In Azure, Azure Content Delivery Network is a global CDN solution for delivering high bandwidth content that is hosted in Azure or in any other location. By using Azure CDN, you can cache publicly available objects loaded from Azure Blob storage, a web application, a virtual machine, or any publicly accessible web server. Azure CDN can also accelerate dynamic content which cannot be cached by taking advantage of various network optimizations by using CDN POPs. An example is using route optimization to bypass BGP protocol. So Azure CDN offers developers a global solution for rapidly delivering high bandwidth content to users by caching their content at strategically placed physical nodes across the world. Azure CDN can also accelerate dynamic content which cannot be cached by leveraging various network optimization by using CDN POPs. Let's look at the cache expiration in Azure CDN. Because a cached resources can potentially be out of date or stale, it is important for any caching mechanism to control when content is refreshed. To save time and bandwidth consumption, a cached resource is not compared to the version of the original server every time it is accessed. Azure CDN caches rules specify cache expiration behavior both globally and with custom conditions. These include global caching rules and custom caching rules. For global and custom caching rules, you can specify the cache expiration duration in days, hours, minutes, and seconds. So that concludes the lecture part of AZ-204. In the next section, we are going to go through review questions for AZ-204. So we just finished the lecture part of AZ-204. In this video, we're going to go through some review questions. In total, there are going to be 49 questions. You have multiple applications running in a single app service plan. True or false? Each app in the service plan can have different scaling rules. The answer is false. The app service plan is the scale unit of the app service apps. If the plan is configured to run 5 virtual machine instances, then all apps in the plan run on all 5 instances. If the plan is configured for autoscaling, then all apps in the plan are scaled out together based on the autoscale settings. Question number 2. Which of the following app service plans is available only to function apps? The correct answer is consumption. The consumption tier is only available to function apps. It scales the functions dynamically depending on the workload. Question number 3. Which of the following app service tiers is not currently available to app service on Linux? Correct answer is shared. App service on Linux is only supported with free, basic, standard, and premium app service plans and does not have a shared tier. You cannot create a Linux web app in an app service plan already hosting a non-Linux web app. Which of the following settings are not swapped when you swap an app? Select all the answers that apply. Correct answers are publishing endpoints, always on, and custom domain names. Some configuration elements follow the content access a swap, not slot specific, whereas other configuration elements stay in the same slot after a swap, which is known as slot specific. Question number 5. Which of the following plans for functions automatically add compute power if needed when your code is running? Select all the answers which is applied to this question. The correct answers are consumption plan and premium plan. Both consumption and premium plans automatically add compute power when your code is running. Your app is scaled out when needed to handle load and scaled down when the code stops running. Question number 6. Is the following statement true or false? The statement is only functions running in the consumption plan require a general Azure storage account. The answer is false. On any plan, a function app requires a general Azure storage account, which supports Azure Blob, queues, files, and table storage. Question number 7. You created a function in the Azure portal. Which of the following statements regarding the direction property of the triggers or bindings are valid? Select all that apply. You can pause these videos in between before I reveal the answer. The answers to the question is: for triggers, the direction is always in. Input and output bindings can use in and out. And some bindings can use in out. All triggers and bindings have a direction property in the function.json file. Question number 8. Azure Functions uses a component called Scale Controller to monitor the rate of events and determine whether to scale out or scale in. Is the following statement true or false? The statement is: when you are using an Azure queue storage trigger, it scales based on the queue length and age of the newest queue message. The statement is wrong, so the answer is false. When using an Azure queue storage trigger, it scales based on the queue length and the age of the oldest queue message. Question number 9. Which of the below are valid application patterns that can benefit from durable functions? Select all the answers that apply to this statement. The correct answers are function chaining, fan out and fan in, async HTTP APIs. Question number 10. Which of the following types of blobs are designed to store text and binary data? The correct answer is block blob. Block blobs store text and binary data up to about 4.7 terabytes. Block blobs are made up of blocks of data that can be managed individually. Question number 11. There are three access tiers for block blob data: hot, cold, and archive. New storage accounts are created in which tier by default? Correct answer is hot. The hot access tier, which is optimized for frequent access of objects in the storage account. New storage accounts are created in the hot tier by default. Question number 12. True or false? All data written to Azure storage is automatically encrypted using SSL. The statement is wrong, so the answer is false. All data, including metadata, written to Azure storage is automatically encrypted using Storage Service Encryption or SSE. Question number 13. Which of the following redundancy options will protect your data in the event of a region-wide outage? The correct answers are read access geo-redundant storage, which is known as RAGRS, or GRS, which is geo-redundant storage. GRS and RAGRS will protect your data in case of a region-wide outage. LRS provides protection at the node level within a data center. ZRS provides protection at the data center level, which is zonal or non-zonal. Question number 14. Which of the below options would contain triggers and stored procedures in the Azure Cosmos DB hierarchy? The correct answer is containers. Stored procedures, user-defined functions, triggers, etc. are stored at the container level. Question number 15. The cost of all database operations is abstracted and normalized by Azure Cosmos DB and is expressed by which of the options below? The correct answer is request units. The cost of all database operations is normalized by Azure Cosmos DB and is expressed by request units or RUs for short. Question number 16. Azure Cosmos DB allows developers to choose among 5 well-defined consistency models: strong, bounded, staleness, session, consistent prefix, and eventual. Which of the statements below describing these models are true? Select all that apply. The correct answers are option 2 and 3. When the consistency level is set to bounded staleness, Cosmos DB guarantees that the client always read the value of a previous write. The next option is when the consistency level is set to strong, the staleness window is equivalent to 0 and the clients are guaranteed to read the latest committed value of the write operation. Question number 17. Partition keys should have many distinct values. If such a property doesn't exist in your data, you can construct a synthetic partition key. Which of the following methods below create a synthetic key? The correct answer is concatenate multiple properties of an item. You can form a partition key by concatenating multiple property values into a single artificial partition key property. These keys are referred to as synthetic keys. Question number 18. An availability set is a logical grouping of virtual machines within a data center that allows Azure to understand how your application is built to provide for redundancy and availability. Is the following statement about availability set is true or false? So let's read the statement. It is recommended that a minimum of 3 or more VMs are created within an availability set to provide for a highly available application and to meet the 99.95% Azure SLA. The statement is false. 2 or more VMs are necessary to meet the 99.95% Azure SLA. Question number 19. Docker is a containerization platform used to develop, ship, and run containers. Which of the following uses the Docker REST API to send instruction to either a local or remote server? The correct answer is Docker client. The Docker client is a command line application named Docker that provides us with a command line interface to interact with a Docker server. The Docker command uses the Docker REST API to send instructions to either a local or remote server and functions as the primary interface we use to manage our containers. Question number 20. What does the following Docker command do? The command is docker rmi temp dash ubuntu version dash 1.0. The correct answer is removed the image with a version. You can remove an image from the local Docker registry with the docker rmi command. Specify the name or ID of the image to remove. Question number 21. The top level resource in Azure Container Instance is the container group. A container group is a collection of containers that get scheduled on the same host machine. Your solution requires using a multi-container group. Which host operating system should you use? Correct answer is Linux. Multi-container groups currently support only Linux containers. For Windows containers, Azure Container Instances only supports deployment of a single instance. Question number 22. In the context of Azure Active Directory, application is frequently used as a conceptual term, referring to not only the application software but also its Azure AD registration and role in authentication, authorization, conversation at runtime. In that context, what role or roles can an app function? The correct answer is both client and resource server role. By definition, an app can function in these roles. Question number 23. What resources or objects are created when you register an Azure AD application in the portal? Select all the answers which is correct. The correct answers are application object and service principal object. When you register an Azure AD application in the Azure portal, two objects are created in your Azure AD tenant. Question number 24. Shared access signature is a signed URI that points to one or more storage resources and includes a token that contains a special set of query parameters. What are the two ways you can sign an SaaS? The correct answers are with the storage account key and with user delegation key. You can sign a SaaS in one of two ways. Question number 25. The Microsoft Authentication Library or MSAL defines two types of clients, public clients and confidential clients. Which of the two definitions below describe a public client application? The correct statement is the app is entrusted to safely keep application secret, so it only accesses web APIs on behalf of the user. It can't hold configuration time secrets, so it doesn't have client secrets. So Microsoft Authentication Library defines two types of clients, public clients and confidential clients. Let's look at the last question in the part 1. With MSAL.NET 3.x, The recommended way to instantiate an application is by using application builders, public client application builder and confidential client application builder. True or false? All of the dot with modifiers can be used for both the public and confidential builders. The statement is false. Most of the dot with modifiers can be used for both public and confidential app builders. There are a few that are specific to the confidential client, which are dot with certificate and dot client secret. Question number 27. Azure Key Vault is a tool for securely storing and accessing secrets. A secret is anything that you want to tightly control access to, such as API keys, passwords, or certificates. A vault is a logical group of secrets. True or false? Azure Key Vault requires that you always pass credentials through your code to access stored secrets. The statement is false. You can use a managed identity to authenticate to Key Vault or any service that supports Azure AD authentication without having any credentials in your code. Question number 28. Below are some characteristics of a managed identity. Created as a standalone Azure resource, independent lifecycle must be explicitly deleted and can be shared. Are the listed characteristics associated with a user or system assigned identity? The answer is user assigned identity. These are characteristics of a user assigned identity. System assigned identities are created as part of a resource and are deleted when the resource is deleted and can't be shared. Question number 29. The Azure Key Vault service supports protocol versioning to provide compatibility with down-level clients, although not all capabilities will be available to those clients. True or false? If you don't specify an API version using the API version parameter key, Vault will default to the current version. The statement is false. Clients must use API-version query string parameter to specify the version of protocol that they support, as there is no default. Question number 30. Azure App Configuration provides a service to centrally manage application settings and feature flags. Azure App Configuration stores configuration data as key value pairs. Which of the below are valid uses of the label attribute in key pairs? Select all that apply. The correct answers are create multiple versions of a key value and specify multiple environments for the same key. Labels add a layer of metadata to the key value pairs. You can use them to differentiate multiple versions of the same key, including environments. And labels are not values. You should never store application secrets in the app configuration. Question number 31. Which of the options below matches the following definition? A security identity that user created apps, services, and automation tools use to access specific Azure resources. The correct answer is Service Principal. An Azure Service Principal is a security identity that user created apps, services, and automation tools use to access specific Azure resources. Question number 32. API management helps organizations publish APIs to external, partner, and internal developers to unlock the potential of their data and services. Which of the below options is used to set up policies like quotas? The correct answer is Azure Portal. The Azure Portal is the administrative interface where you set up your API program. Question number 33. In Azure API management, policies are a powerful capability of the system that allow the publisher to change the behavior of the API through configuration. Which of the options below accurately reflects how policies are applied? The correct answer is all of the above. A configuration can be divided into inbound, backend, outbound, and on error. The series of specified policy statements is executed in order for a request and a response. Question number 34. A control flow policy applies policy statements based on the results of the evaluation of Boolean expressions, true or false. A control flow policy must contain at least one otherwise element. The statement is false. The control flow policy must contain at least one when element. The otherwise element is optional. Question number 35. The return response policy aborts pipeline execution and returns either a default or custom response to the caller. What is the default response code? The correct answer is 200 OK. The default response is 200 OK with no body. Question number 36. Regarding Azure Event Grid, which of the below represents the smallest amount of information that fully describes something happening in the system? Correct answer is events. An event is the smallest amount of information that fully describes something that happened in the system. Every event has common information like source of the event, time of the event took place, and unique identifier. Question number 37. Azure Event Grid has three types of authentication. Select the valid type of authentication from the list below. The answers are custom topic publishing, event subscription, webhook event delivery. Azure Event Grid has these three types of authentication. Question number 38. Azure Event Hubs is a big data streaming platform and event injection service. What type of service is it? The correct answer is PaaS. Event Hub is a fully managed platform as a service with little configuration or management overhead. Question number 39. In .NET programming, which of the below is the primary class for interacting with Event Hubs? The correct answer is Microsoft.Azure.EventHubs.EventHub client. The primary class for interacting with Event Hubs is Microsoft.Azure.EventHubs.EventHub client. You can instantiate this class using createFormConnectionString method. Question number 40. Which of the following advanced features of Azure Service Bus is used to guarantee a first in, first out guarantee? The correct answer is message sessions. To create a first in, first out guarantee in Service Bus, use sessions. Message sessions enable joint and ordered handling of unbounded sequences of related messages. Question number 41. In Azure Service Bus, which of the following receive modes in best for scenario in which the application can tolerate not processing a message if a failure occurs? The correct answer is receive and delete. Receive and delete mode is the simplest model and works best for scenarios in which the application can tolerate not processing a message if a failure occurs. Question number 42. In Azure Queue Storage, what is the default time to live for a message? Correct answer is 7 days. The default time that a message can remain in the queue is 7 days. Question number 43. In Azure Queue Storage, which two methods below are used to dequeue a message? Get message and delete message. Your code dequeues a message from a queue in two steps. When you call get message, you get the next message in a queue. A message returned from the get message becomes invisible to any other code reading messages from this queue. By default, this message stays invisible for 30 seconds. To finish removing the message from the queue, you must also call delete message. Question number 44. The application insights .NET and .NET Core SDKs ship with two built-in channels. Which channel below has the capability to store data on a local disk? The correct answer is Server Telemetry channel. The Server Telemetry channel has retry policies and the capability to store data on a local disk. Question number 45. True or false? The URL ping test in Application Insight uses ICMP to check a site's availability. The statement is wrong. So answer is false. The test is not making any use of ICMP to check your site's availability. Instead, Application Insight uses more advanced HTTP request functionality to validate whether an endpoint is responding. Question number 46. In the cloud, transient faults aren't uncommon, and an application should be designed to handle them elegantly and transparently. Which of the following are valid strategies for handling transient errors? Check all that apply. The correct answers are retry after a delay, cancel, and retry. Retry after a delay, retry, and cancel are all valid strategies for handling transient faults. Question number 47. Data in Redis cache is stored in nodes and clusters. Which of the statements below are true? Select all that apply. The correct answers are nodes are a space where data is stored and clusters are sets of 3 or more nodes. 48. True or false? Azure Redis cache resources requires a globally unique name. The statement is true. The Redis cache will need a globally unique name. The name has to be unique within Azure because it is used to generate a public facing URL to connect and communicate with the service. Let's look at the last question. The Redis database is represented by the iDatabase type. Which of the following methods creates a group of operation to be sent to the server and processed as a single unit? The correct answer is create transaction. The create transaction method creates a group of operations that will be sent to the server as a single unit and processed on the server as a single unit. So thank you so much for taking your time to go through this content. I wish you all the very best for your examination and I will see you on a next tutorial. Until then, take care.